Wavy Boy Productions. Wavy Boy Productions.
Happy Monday, everyone. Welcome to another week of Mastermind Academy. I think this is week number 8. So we're getting there. Week number 8. So 4 more weeks after this. Welcome. Hope everybody's doing pretty good. What time is it? 8 o'clock, getting started right on time. And I'm doing my best to make sure. I think I've gotten all but one stream. I think I started one stream at 8:01. But looks like we're started on time. Just making sure everything is good. Just checking all little metrics from Streamlabs, making sure the stream is actually uploaded, not dropping any frames. We're looking pretty good. Do I have any announcements? I guess, oh yes, I have a big, not a big announcement. Next week, actually let's pull up let's actually put up academy.mastermind.io. Next week's Wednesday stream, I'm actually gonna do the stream. I'm actually traveling. I'm going to a conference, but I'm gonna do the stream live on Tuesday night. So this would be the October 9th stream, and I'm gonna post this up on social media as well as update the site. So the containers part 2. So we'll do containers part 1 on Monday, next Monday. Containers part 2, which is supposed to air Wednesday. We'll do that live on Tuesday, so you can ask any questions if you can make it. If you can't make it, no big deal. It's going to, I found out about the replay feature in Twitch, so we can live stream it, we can live record it on Tuesday, do it live, and then on Wednesday at the same time it will replay Tuesday night stream. So that's how I'm gonna handle that. I was gonna pre-record it once I realized I was traveling, but yeah, I'll do it live on Tuesday. So hopefully you can make it. No big deal if you can't. It will replay on Wednesday. So that's a pretty cool feature of Twitch. So it might be also nice because containers is like one of my favorite things to teach, and going straight from part 1 to part 2 might be kind of nice to kind of knock out 2 things at once and kind of get the rest of your week back. But yeah, other than that, I don't think I've rendered and posted the past 2 courses, past 2 streams for YouTube. So I will try to do that tonight. I'll try to get those rendered and uploaded tonight to make sure that that we're all up to date there. I think there's 1 through 11, I believe, on YouTube. So 12 and 13 are not up there yet. But let's talk about what we're doing tonight. What are we doing tonight? Let's talk about what we've done so far, actually. So if you're new to the stream, we've been doing this since August 12th, twice a week. We've missed 1 stream so far. We missed a lab day, and I'm still thinking of some good ways to reincorporate that. It's kind of grown since then. I keep adding to it because of how much we've learned, and I want to be able to make sure everyone gets to use all the stuff we've learned. So we may do another like Tuesday lab or something like that a little bit later. I'm trying to figure out how to make that work. But so far we've gone over programming languages. We've gone over the basics of programming. We use Golang, but you could use any language. We've gone over operating system concept. So we learned Linux. We learned basic Linux commands, Linux command line. We learned how to kind of manage a Linux computer, adding users and groups and installing packages, etc. And then we did a little lab with that with some bash scripting. We learned a little bit about networking security, different protocols. We learned about web servers with Nginx and web traffic management, and how load balancers and firewalls worked and proxies. And that was the checkpoint lab that we were supposed to do that we did not get to do yet. So this is the one we skipped. If you are new to the stream, that we will try to catch up on. Then we started talking about the cloud. So I think 2 weeks ago we started learning about AWS. So we chose to dive into some of the main services and resources they had. We learned a little bit about how cloud computing works, and the different services that cloud computing has to offer and how you can use those things. So we ran through, obviously we did not run through all of them because AWS and Microsoft Azure have tons of different services. It's way too many, but we ran over some of the main ones. And then we did a pretty cool lab with Lambda to show how you could use serverless technologies and serverless functions to quickly set up little endpoints that you could hit to make some cool things happen. And now we're in the infrastructure as code piece. So this part is very exciting to me because I actually think when people say DevOps, I think usually what jobs want is they want someone who knows this section, the infrastructure as code section, the container section, and the continuous integration, continuous delivery, continuous deployment. Actually 4 sections. So the cloud computing, the infrastructure as code, and then the container and the continuous delivery and deployment. Those all kind of fit together. We'll see how they all fit together. But this is why it's kind of fun to get into the main meat and potatoes of this stuff. So we're going to take everything we learned, and we're going to kind of throw some of it out the window tonight with this infrastructure as code piece, and we're going to see how we can deploy infrastructure as code, spin up resources with code rather than by hand, which is pretty cool. We'll talk about why that's great. So yes, how's everyone doing? Is there a playlist? Yeah, I can get you the entire playlist for this. The intro video, I just switch up the song every so often. I'll probably switch it up next week. But yeah, I can definitely send over which Spotify playlist this is. We like the Lambda Lab, Azure Functions. It's although it's fairly easy to get up and running, especially with frameworks like serverless. You'd be surprised at how complicated it can get, and the cool things that you can do with Lambda and serverless. It really changes the way that you think, and if you can figure out how to think outside the box, you can solve some cool problems, some cool ways using serverless technologies. Let's see, Monday, cool. Dublin, Ireland in the house, awesome. 1 a.m. Tuesday morning, you are dedicated. Thank you for joining the stream. That's pretty awesome. It's 8 o'clock here. I'm on the East Coast of the United States. I'm in Baltimore, Maryland. But awesome. I always love to hear when people are here from other places, especially outside of the country. So welcome to the stream. But 8:06, let's go ahead and get started. Tonight, actually, I don't think is going to be that. Terraform is surprisingly, I think, easy to get up and running with and to get started with. So I think this will be a relatively easy one compared to the Lambda Lab. We'll get hands-on. We'll actually provision some infrastructure tonight and we'll write some code. So let's get started. Let's hop right into the Google Slides and then we'll get hands-on. So let's present here. So infrastructure as code. Repeatable, reliable, consistent. That is the goal kind of DevOps. That's kind of the goal of SREing. That's kind of the new wave. That's kind of what cloud computing has kind of enabled. Cloud computing and kind of this cool tooling has kind of enabled you to really build repeatable, reliable, and consistent infrastructure. And we're gonna learn how to do that tonight. So what is IAC? And so I wrote it this way. You'll see this a lot. You'll see infrastructure as code written in this notation a lot. What is it? So infrastructure as code, and I got a little example here. Function build via server. So we talked about functions during the programming portion. And again, this is a reusable piece of code that does a specific task. But let's talk about the Wikipedia definition first, which almost always you're going to get the Wikipedia definition first, and then we will break it down. So infrastructure as code, or IAC, is the process of managing and provisioning computer data centers through machine-readable definition files, rather than physical hardware configurations or interactive configuration tools. Okay, let's break it down. And this picture on the left is exactly what infrastructure as code is. I think it's a good illustration of what it is. You see here on the left, we got some files, and it's got some the representation of code written inside these files. And you write your code and you send it off, and maybe there should be a picture of like AWS or Azure right here in the middle, and then all these computing resources. So these are laptops, but they're not actual computers. They might be, they could be, but they're representations of computing resources, cloud resources in particular, on how we're going to be thinking about it tonight. But yeah, you kind of pass this along, you write code, and then it gives you this stuff over here, which is pretty cool, and it's pretty simple, and there's a lot of benefits to that. So what are the benefits? Why infrastructure as code? Why would you want to practice infrastructure as code? Why would you want to use it? So one, it creates a consistent and reusable way to deploy and manage infrastructure assets configuration. So let's break that down. Consistent and reusable, that's the first piece. So we learned about functions, we learned about writing a piece of code that you could use over and over again. But if I manually, the same way that we've been doing things, if I manually go in and we talked about EC2 instances. We should know what EC2 instances are. We spin up an EC2 instance and I configure it with, this one has Nginx, and, I put a new key on there. I created a new key, and, I added some users. We went in and we were running through a lab and we added some users, and it's great. And people are using it, and, we're getting hits to that server, and then it goes down or something happens, or we need to replicate it. How can we do that easily? Usually it used to be you would order another server and you'd have to install the software onto it and, install the operating system, plug it up, rack it, all that stuff. But we want this to be consistent across the board. We want to be able to create a replica of the server that we have now. So being able to codify this allows you to do it over and over again, exactly the same, which is really, really nice and really, really handy, especially for enterprise users. But really, it can be used for everyone. Yeah, so it helps prevent configuration drift. So imagine, just like we were just talking, imagine we have multiple servers. Maybe we have 6 of those Nginx servers, all with their own configurations on them. Let's say they're supposed to be the same. When we first configured them, they were all the same. We configured all 6. We went in, we followed, we had written down a script of all the dependencies, all the packages that we needed to install, all that stuff. But let's say one of them was having a problem. We've got some monitoring in place. Server number 3 is having a problem, and I go in and I see that there's some issues, and I think to fix this problem, I need to change a parameter in a file. And I go in and I change some configuration on one file on one of these 6 servers that are all supposed to be the same. And now I come off of there, and now we have one server that's actually not the same as all the rest. And so it may operate for a while and it may look good. And then someone might make another change on another server and another change on another server. And now we have 6 servers that just aren't the same anymore. And we don't know which one's the right configuration. We don't know what's what or what's supposed to be. We don't know what things are supposed to be set to. And so infrastructure as code also helps. It helps mitigate that. It makes sure these servers and their configuration do not start to drift apart. Then we have free documentation. So what does that mean? So actually the Academy website is designed to resemble technical documentation, and there will be a lot more stuff here, but technical documentation is a way for you to, or a way for you to document and to write down what your code or your application is supposed to do and how to use it. And documentation is very important. And when you get a new engineer on the team, you want to have that documentation. It's kind of hard to. A lot of companies have a problem keeping up with documentation because it's something you have to actively do. It's time consuming, and everyone's not a great documentation writer, but what you get from infrastructure as code is free documentation. So I can join the company. If they're using something like Terraform, I could take a look at the Terraform files. I can look at the Terraform repo, and I can say, okay, all right, I can look through and I can see, oh, it looks like you're spinning up, this many EC2 instances in this availability zone in this VPC, and you have this many VPCs, and you have this many EBS volumes that you care about, and this many RDS instances, and they're connected over here. But you can see all that stuff. Obviously, you have to be familiar with the code. Like, you have to know, whatever infrastructure as code tool you're using, you have to be familiar with that code, but it is essentially free documentation for you to use. It's not on here, but not only is it free documentation, but that documentation is also can be version controlled. So we talked about Git very briefly, and we need to do an entire Git lab, because Git, not the product Git lab, we need to do a lab on Git. But that tool, Git, that version control really is beneficial in figuring out, what changes have been made to your infrastructure. And some of the tools provide that internally, but it's a great way for most people to be able to work on a code base, as well as figure out what's going on there and what happened there. And then speed. So speed is great. So you can deploy things really fast with infrastructure as code. You can move pretty quickly. You can make changes to lots of servers all at once with infrastructure as code. So you can move a lot faster than if you had to log into 20 servers and make changes by hand. And then it's just automated infrastructure. So the name of the game when it comes to DevOps is to automate all the things. And you also want to automate your infrastructure. You don't want to have to manually provision any infrastructure, because it is time consuming and your time is valuable. So you kind of want to we're working towards being as lazy as possible. Put in a lot of work up front, join the company, put in a lot of work up front, and sit around for the rest of your days there, while everything just kind of takes care of itself because you did a great job in the beginning. All right, so now we know why infrastructure is code. We know what it is, and we know why it is now. And then I have this here. Pillars might not be the right word. Couldn't think of a better word while I was creating these slides. But what are the pillars of infrastructure as code? And I really broke this down into 3 layers, because there are 3 different, I think, classes of what I would consider to be infrastructure as code. And this is kind of, you probably won't find this like wording or this breakdown anywhere else. I didn't find much on this. People kind of split them up into two, really, but I think there are three pillars of infrastructure as code. One be infrastructure provisioning. So provisioning, meaning actually building these things, actually creating the real resources. So if there's no S3 bucket, now you say I want an S3 bucket. Whoops. And then there is an S3 bucket. Like that's what provisioning is. It's a real resource. So we're not running a piece of code. We are saying, hey, I want this actual resource that I'm probably going to be paying for. I want you to give me a real tangible resource. So give me that EC2 instance, and the EC2 instance gets spun up, and now you can log into it, etc. That's infrastructure provisioning. That is actually building the actual infrastructure and assets. Then there's server and software configuration management. So I like to break these two things off, but and we'll talk about what tools kind of go into these in a second. But server and software configuration management is once you spin up this infrastructure, once you provision the infrastructure, these are just these computing resources. How do you get them set up automatically how you want them set up? So, when you spin up an EC2 instance by default, it'll be empty and there'll be nothing on it. How do you get the things that you need? If you want Nginx installed by default, if you want these users set up by default, if you want these scripts to run by default, how do you get that done? And server and software configuration management is how you would do that. And the third piece, which people will probably have been doing for a long time, is scripting. So scripting is a form of infrastructure as code, and it is used to be able to get infrastructure into a state that you'd like, and to be able to manage infrastructure. You should be able to, Rod, you should be able to post links. Sometimes Nightbot is a little aggressive, but you should be able to post links. No problem, I believe. Cool. So provisioners, let's start with the first pillar. Some of provisioners, again, provisioners allow you to define and build infrastructure assets from a source file. So again, putting into a file that says, hey, I want an S3 bucket, and it gives you an S3 bucket. I want an EC2 instance with this much memory, with this much RAM, and it gives you that real tangible asset. And these are some of the provisioners. When people talk about provisioning, these are some of the tools that they're talking about. So Terraform is probably one of the largest ones for sure. And that's the one that we're gonna be using tonight. Terraform is great because it's cross-platform. It has a module system that gets built so that you can use different providers to be able to work with multiple vendors. So it's not AWS only. You can use it with Azure or Google Cloud Platform. There's a bunch of other other providers that we will take a look at. We'll take a look at that list once we hop into it. So Terraform is great. Again, probably the biggest, one of the largest on this list. Pulumi is also another one that's similar to Terraform. It's newer to market. It's still growing. It doesn't quite have the same backing, doesn't quite have the same documentation, but it is a pretty cool tool. I will recommend checking it out. I want to say all of it is written in Node, I believe, Node.js. So if you like Node, you might want to check that out, but it's also free and open source. So you can check out Pulumi. It is a good product. Then we have AWS CloudFormation. So I was going to go over AWS CloudFormation, but I determined that not really necessary. Again, the concepts are what matters. You're gonna walk away from today knowing how to use Terraform, and you'll definitely be able to spin up some infrastructure with it, but you won't be an expert in it at all. But AWS CloudFormation is Amazon's provisioner. It is Amazon only, so you can only deploy Amazon resources with it. And in comparison, the way it's written, it's much more complicated. It's much more complicated to use, to be honest, or to get up to speed on. Once you get there, it makes sense, but it's much more complicated. The one benefit is that Amazon comes out with new resources so much and updates their resources and their services so much that AWS CloudFormation is kind of the first to get updated to be able to use these new things, these new tools, these new features. But again, it's hard to learn. It doesn't make a lot of sense when you first look at it. It's hard to read. So we're gonna skip over that, but you do need to know. I do think it's important that you know what it is, especially if you're interested in doing things with AWS. And the last one I have on here is Vagrant. A lot of people don't think of Vagrant as one of these, but Vagrant is absolutely this. So Vagrant is a tool also by the same company, HashiCorp. HashiCorp has a few products, but Vagrant has been around for a while, and Vagrant is used to build development environments, or so basically it's used to configure and pre-build kind of virtual machines, and it's a pretty cool product. So if you're using VirtualBox, things like that, you can set up, you can use Vagrant to build, an image for you to use and to be able to, pass around to people. Vagrant is pretty cool. All right, so those are all the provisioner vendors. So this is the second bullet point on there. So I said software and server configuration management. So you hear this a lot. You will see configuration management on a lot of DevOps and SRE job descriptions. So this is what they're talking about when they put configuration management on there. So actually, let me stop for a second. Is Vagrant kind of like Packer then? Yes, Vagrant is similar to Packer, and we're gonna go to the HashiCorp website, and I'll kind of show you some of the differences. Vagrant is similar. I use them for different things. I think there is some overlap there. I think usually I build AMIs for Amazon with Packer, but you can build AMIs for AWS with Vagrant. There's definitely overlap, but there's definitely overlap, but they work in different ways. You can use them to achieve the same goal. There's a lot of overlap in all of these though. You can use some of these provisioners to achieve some of this configuration management stuff. Some of these configuration management items have some provisioners. There's a lot of overlap, but they are different tools that have a different end goal in mind. And we'll talk about that when we get to the website. Cool. So configuration management in DevOps. Configuration management is an automated method for maintaining computer systems and software in a known, consistent state. That last line is very important. Known, consistent state is very important. So you can see here, we've got Al Roker, and we've got the same Al Roker over and over again. And that is what configuration management is. It's being able to set up Al Roker with a tie, the same tie with his little handkerchief in his pocket, same color shirt, same blazer, same little salute that he's giving, same glasses. And that's what configuration management is being able to take a bunch of servers, define your configuration. So again, I need Nginx running that's set up to serve these 3 different sites. And I also need, I want WordPress installed on the back end, and I want these files in this location, and I want these users, and not only do I want Nginx installed, I want to make sure Nginx is running, and I want you to start Nginx, and if it dies, I want you to make sure it's running. So again, that known consistent state. So what that means is you'll define these things, and let's say we have 20 servers, and I'm messing around, I'm troubleshooting a problem on one of the servers. And let's say I shut off Nginx because I want to test something. I shut it off and I forget to cut it back on, which isn't a big deal if you've got some redundancy there. And you might not notice, but a lot of configuration management services will poll or check in every so often, whatever interval you give it, maybe every 30 minutes. It'll say, hey, I'm going to check in with server number 12, the one that I shut Nginx off on, and I'm going to make sure it matches this file. And it's going to run through, and it's going to say, all right, that user is there, Nginx is there, these files are in place, but Nginx doesn't appear to be running. I'm going to do my best to get it in a running state, and it's going to start up Nginx for me on that server, which is pretty cool. So you don't really have to worry about, again, that configuration drift, and you've got this tool making sure all your servers are consistently aligned and have all the same configuration, which is really great. So if something changes, it'll reset it for you, and you don't really have to worry about messing things up, which is really, really, really nice. Yeah, and so let's take a look at some of these vendors for here, some of the big players. So configuration management will be people like Chef and Puppet, Ansible, and SaltStack. There's a few others in here. There's like something called like Fabric, which is like built off of Python, and there's a few others here. But again, I said there was a lot of overlap here. It looks like people are talking about that now. Yes, Chef does actually have it's almost a separate tool. It's called Chef Provisioner, I believe. And all of these have the ability to deploy resources for you, to deploy Amazon Web Services or Azure resources for you, and also configure those things. But in my experience so far, they've kind of just provided you this as like hey, here's a tool that we wrote pretty quickly, but it doesn't have the same doesn't have the same configuration options. It doesn't have the same breadth of features that something like one of these options has, but it will work, especially for smaller use cases. So a lot of companies use a combination of 1, 2, or 3 of these tools, to be able to provision their infrastructure and configure them appropriately and make sure they are in that known and consistent state. We are actually going to be using Ansible, and we're going to be using that on Wednesday. So after tonight, if you're interested in learning, how we do this piece of it after we provision it, we'll be using Ansible next stream. I probably have the most familiarity with Chef. Ansible's cool. I like Ansible. But yeah, they're just different tools, and they're pretty good at keeping those servers in a consistent state. All right, and I think that's the last one. That's the last one that last slide we're gonna have. And now it's time to get hands-on. So I'm gonna stop for a second. Ask any questions you have. If you have any questions about anything we covered so far, these concepts I think are relatively. I think they're relatively simple. I don't think they're quite as complicated as some of the other stuff that we've talked about, but it's basically, we're gonna write some code. We're gonna put some lines of code into a text file. We're gonna pass it through a tool, or straight over to Amazon. Well, we're gonna pass it through a tool, through one of these softwares, write some code, pass it through one of these softwares, and it's gonna interpret that, and it's gonna go ahead and give us infrastructure. That's why it's called infrastructure as code. So fairly straightforward there. All right, I can do some infrastructure provisioning. Yep, that's better for that. Perfect. Thank you. Spill my drink. Should fall short for setting up a DB from scratch. Yes. All right. So actually, cool. So I actually spent a bunch of time setting up sorry about that. Setting up a kind of like a custom lab for this, and then I actually checked out Terraform's quick start guide, and I think it's perfect for what we want to do tonight. And we'll add on to the quick start guide. We're gonna go through and actually follow Terraform's actual learning quick start guide, because one, again, I think it's great for us to practice going through documentation, and I think they did a great job. And we'll definitely be able to get through it in the time that we have left. We'll probably be done. Honestly, we might be done in a half an hour early, and we can mess around some more or talk about some more things. But let's go ahead and hop into that. So if you hit the command !Terraform, it'll go ahead and it'll give you the link that we're going to be going off of. So if you want to go ahead and follow along, we are going to be using that exact link. And let's see here, HashiCorp Learn. It's make it a little bit larger, and yeah. So actually, let's before we hop into it, let's go into HashiCorp site. Let's talk about HashiCorp just a little bit. HashiCorp is a pretty cool company. They make a few different products. So you can see here they have 1, 2, 3, 4, 6 different products. And I think their website's pretty informational, and pretty good about explaining what these things do. So again, something we talked about before, Packer. It says it right here, right up front in your face, so you kind of know what the tool does without having to dive too much into it. But build automated machine images. So again, we talked about Amazon machine images. You can use this to build VMs. You can use this to build machine images for other services. It's a pretty cool tool, and it's I love Packer. Packer's really nice. It's interesting because even in HashiCorp's walkthrough here in their learn of Terraform, they're going to talk about the need that if you're using Packer, that you probably don't need to worry about any configuration management, probably. And so this is kind of taking away the need for a lot of people, given the right environment, for things like Chef or Puppet or Ansible. But again, they all have their place. It can also be used in conjunction. So Packer is pretty cool. And let's just run through their tools. Vagrant. Development environments made easy. Yeah, this is probably more of a Chef or Puppet system configurations. It's more of a, describe what you want this developer machine to look like, and it will go ahead and it will provision that for you. So Vagrant is pretty cool. Vagrant has been around for a while though. At least, I've known about Vagrant for a long time. It's probably the first HashiCorp product that I ever used that I didn't even know was a HashiCorp product, but I've used Vagrant a lot. Nomad, I actually don't know what Nomad is. I saw it at a conference, and it seems like it's some kind of container orchestration tool, kind of like Kubernetes, or like maybe more like Docker Compose or Docker Swarm, maybe. So if somebody knows what that is, let me know. Yeah, maybe that's what it is. I'm not 100% sure, but that's what it seems like. That it seems like some kind of container orchestration tool. So if you want to check that out, check that out. Maybe we'll check that out on a side stream or something one day. What else do they have? They have Console. So Console is an interesting tool. It's yeah, it's an interesting like service discovery tool that you can use when you're spin up a lot of applications. Yeah, it's a cool tool. Most you probably will never need this for your own like little if you're working on a little project or trying to get up and running with something. You probably don't need Console, but Console's cool. I guess I haven't used it a ton, but HashiCorp Vault is great. So this is secrets management. So after you'll understand secrets management a little more after we go through some of the stuff tonight. But basically, what happens is when you're writing out code and you have this pushed up to GitHub and things like that to provision your infrastructure, how do you handle like database passwords and application passwords and things like that, and keys and things like that? Like, how do you manage that stuff in a safe way? HashiCorp Vault is a tool to do that. It's a pretty popular tool, and it works pretty well to be able to on the fly retrieve important secrets data. So secrets are very important, security is very important, and Vault helps you do that. And then we have Terraform, the product that we're going to be using tonight. And again, right here it says it up front. It says provision and manage any infrastructure, which is great. I like how they put any infrastructure in there. It's not any infrastructure, it's most infrastructure. It could be any infrastructure, provided that someone writes the code for it. But yes, this is I think all of these tools, except for maybe Console and Nomad, are open source. I believe that those two might be open source as well. I just don't know that much about them. But let's go ahead and hop into the learn path with Terraform. So on their site, we've got the learn button here, and you get to this great learn page. I was actually really impressed by this, and I actually might have to steal the way this is set up and see if I can build out some type of either Hugo template or a Gatsby template that kind of serves up information like this, because I would love to have something like this to be able to build some courses with. So this is great. So hop on over to this site if you want to follow along. I'll be sharing it the whole time, so no big deal. If not, we're gonna start from the very beginning. I don't think I have Terraform installed on this computer, so we'll start from the very beginning, and we will install Terraform and start building infrastructure, change it, destroy. So it runs through a lot of different things tonight, and we're gonna learn. And you can see here, even it has a time limit here, like how long it should take. Which is great, and they're all short. So I really like tutorials like this to kind of get through and focus on the concepts rather than having to worry about like all the syntax and everything else. But cool, let's do the first piece and let's go ahead and get Terraform installed. And so you have a bunch of options here. So you can either use Mac OS and Linux or Windows, and they have a whole video here, but we're not going to need to watch the video. We are going to go ahead and basically one of the great things about Terraform is it's written in Go, so they can just make these little executables for you to install locally. But you can go ahead and click on the appropriate package thing. So you want to go ahead and install the appropriate package for your computer. Very simple, not a hard thing to figure out. Either you're on Mac, probably Linux or Windows. Again, most newer computers are going to be 64-bit, but you'll probably have to choose that there. But we're going to go ahead and grab the 64-bit version. And I'm going to go ahead and save this to a file. I'm going to let that download to my computer. So that should be good and downloaded to my computer. So once you have that, let's go ahead and read through. It just lets us know, hey, it's going to be a package. That's a zip archive. And after you download it, you're going to unzip the package. So we learned how to do all these things in the managing operating systems unit. And so we're going to download it, which we just did, and then we're going to unzip the package. Terraform runs as a single binary named Terraform. So again, it's using Golang, so they were able to ship it off as a single binary that you can basically just execute, just click on, and it'll run. Any other files in the package can be safely removed and Terraform will still function. Excellent. They made our lives really easy. They basically gave us one little executable to run and it should work fine. And then the final step is to make sure that it is in our path. We'll talk about our path. I don't think we talked about path in the Linux section, but let's go ahead and get that installed. So we're going to hop straight into our terminal. And I went ahead and first let me go into my documents just because this is how I like to organize things. I like to just throw files and stuff like this in my documents. So I'm gonna just make a folder really quick because tonight we're talking about Terraform. Can't type. All right, so I have a directory here, and I'm gonna go into the Terraform directory. And I'm gonna clear, there's nothing in here, which is great. I'm gonna go ahead and take the file that was downloaded to my computer and move it into here. So you actually don't need to do it from the command line. Again, this is good practice. It downloaded to my computer and I could just go right into this folder and unzip it. You could do that and you can move it to wherever you wanted to move it to. But again, we're trying to get good with tech. We're trying to practice these things. So we're gonna go ahead and use the command line as much as possible. So I'm gonna go ahead and copy that file into here. So I know it's in my downloads directory and I know the path to my downloads. You might have to figure out the path to your downloads. One of the ways you can do that is just kind of clicking through here. I can see that my downloads folder is like underneath home. And we know that tilde is a shortcut for home. So this is actually the same thing as /home A Brooks downloads. Same thing, tilde is just a little shortcut. And so I want to copy that file. That file is called Terraform, whatever. We have autocomplete, so we don't care about that. So we're gonna type in Terra and hit tab, and that's gonna fill out the name for us. And they said it was a zip file, a zip archive, and then we just needed to unzip it. So we're gonna copy that into this folder, just because I want to work with it right here. I could have worked it from there, but I want to work with it from right here. Cool. So we've got this here. We can see it's set up. We can go ahead and we can unzip this file. So we know to unzip, it's this the same thing as if we were to go into here and right click and open with Archive Manager, or on Windows, it should say something like unzip. And this is the command that will go ahead and unzip for us. Unzip may not be installed for you by default if you are on Linux or Mac OS. You might have to install it with either brew or apt or yum or whatever you're using, but we're gonna go ahead and unzip because we've done this previously. And let's check out what is now in our directory once we've unzipped it. Awesome, exactly what they said. So they let us know that there will be a single binary, no other files will be needed. So just to clean this up, let me go ahead and rm-rf Terraform _ just to clean up the directory. I'm gonna go ahead and remove that zip. That's why I just copied it up here instead of moved it, so that in case we need it again or in case we made a mistake, we can grab it later. But, all right, we've got this single executable, and so let's execute it. It's there. This is the common executable command in Linux. You do a / and you call the name of the executable. And if I run it, just like if we ran some other Linux command, it lets us know how to use Terraform. It says Terraform, we can give it -version or help. And these are the available commands for Terraform. So if we had no idea what we were using, this would give us some indication on what we're using and how to set it up, or how to pass it commands. So we can also give it, /Terraform, little -help. I think it'll give us much of the same. Yeah. Or we can do -version, which actually, this part is actually very important. So it says we have version 0.12.9. So version 0.12 was actually a major rewrite for Terraform. So if you've ever messed around with Terraform before, some of the stuff we do tonight may not work for you if you have an older version installed in your system locally, because again, it was a major rewrite. And now this new rewrite actually made it much easier. I think the code is much cleaner, much more well thought out. It's much easier in the way that you implement things now in 0.12. And I don't even know a crazy amount about Terraform. I messed around with it before it was version 0.12, and I messed around with it after, and there was a substantial, to me, difference in approachability. I think it's a lot easier now to learn, even though it's pretty easy to learn before. So what we can do now is, so let's hop into what they said in the second part. So the final step is to make sure that Terraform binary is available on the path. See this page for instructions, and they have a page here for instructions. I'll click on it, and it's funny. It's really funny that the official Terraform documentation takes you straight to, instead of like another set of documentation that they wrote or that someone else wrote, they take you to a Stack Overflow page. So I let you know that obviously in this industry, it is very, it's encouraged to Google around. So if you don't know what Stack Overflow is a web resource where people go to ask technical questions about programming, about technical things, and they almost all like, people answer them. It's a great community. You'll get your question answered, or you'll get people who've run into the same problem and let you know, hey, there's no fix for this. But Stack Overflow is where you're going to go to get most of your answers for anything that's code related. Anytime you got to write some code and you Google, Stack Overflow is going to come up, and your answer is probably going to be on there. So it's very interesting that their official documentation takes you over to the Stack Overflow page. And I'll make this a little bit bigger, and I will paste this in the chat in case you want to head over to learn how to add things to your path. But I don't know a good way to explain what path is, but what path does allow you to do. Actually, let me set something up really quick. Input, mouse integration. All right. So what it does allow you to do, though, is to call binaries from wherever you are, from your from wherever you are on the system. So right now, if I tried to call Terraform, I couldn't call Terraform, and it wouldn't execute as a normal Linux command. So when you type commands like ls or cat or any other Linux commands that we learned, these are actually just these are executables that are actually just in our path, so they exist somewhere. So if I use the which command, and let's say I do which ls, it looks like it tells us where the executable is. So if I do ls-la/user bin ls, so we can actually look at it, you can see here that this is actually just an executable file that's in this folder. So ls is simply an executable that is in /user/bin. So the same way that Terraform is an executable, and when we call it, because it is in our path, we can go ahead and we can run it. So what we can do is, there are a few ways you can do this. You can do exactly what they tell you to do here, and you can go ahead and run this command that basically exports your path profile. So if I echo $path, this is just, path is just a system variable, and basically anything that are in these directories, the directories that are they're delimited by a colon, so that's one directory. Anything that's in here or here or here, any executable that exists inside there will be added to my path, and I can go ahead and use that from anywhere. So what I could do is I could add whatever location Terraform is. So how do we find out where we are on the machine? We type in PWD, stands for present working directory, and we go ahead and hit enter, and we find out where we are. So I could add this entire directory structure to my path, and I will be able to call Terraform. But I don't like to do that. I don't like to muddy up my path variable. And an easier way to do this, again, is to do something like which ls or which top or something, whatever common commands you use. You can see that they're in user bin, and I'm just going to copy Terraform into that location, because again, if it's there, it will run. So I'm going to copy Terraform into /user bin. And cool, immediately I get a permission denied because this user bin directory is a little special, but you can also just solve that by doing a sudo to escalate your privileges, and go ahead and enter your password. And cool, so that's been copied into user bin. So if I actually do an ls on /user bin, it's probably a lot of stuff in here. There's a lot of stuff, but there's way too much stuff in here. Let's see if we can get up to the T's. I could have just did Terraform, but just want to show you that it is here. So I copied it in. I just copied it in today on September 30th, and it is here, and so I can run this. So if you ever are confused about what applications or tools you have available to you, whatever Linux commands you have available to you, you can hop into this directory and see what is in there. So I should be able to run any of this stuff. But cool. I don't need any of this. And so I'm gonna clear this screen. But now the Terraform's there. If I type in TER and hit tab, it autofills for me. It auto-completes for me because, again, this is in my path, and now I can run it. So if I just hit Terraform, it's just like any other Linux command. It is just executing that executable. So that's the first part of getting Terraform installed. And I think we have completed that section. And again, so verifying your installation, you just type in, if you want to make sure it's installed, you just type in Terraform, you execute the Terraform command, and you should be able to see all the available commands. That is how you know that you were able to get it installed. And we've already done the first piece of it. We've already got Terraform installed, still with plenty of time left to do some cool stuff. So I'll give anyone who's still working on that a few, minute or so to see if you can get there. Yeah. Are all 24 episodes about Terraform? They are not, and I probably should have named this a little different. Maybe I'll change the naming convention. Was it Mable? They're not all about Terraform. Only this one is about Terraform. This unit is about infrastructure as code. I don't know if I put it in a command that'll give you was it academy.mastermind.io. This is we cover a lot of different things. I think so on Wednesday we're covering Ansible, and then I think we're doing containers next week and container orchestration the week after, and then some CI/CD tooling the week after that. So we're covering kind of all the different tools and tooling that you would need to do DevOps, even though it's not really a job. It's more of a method of operation. But yeah, to do the things that are necessary from a DevOps engineer or site reliability engineer. But yeah, just kind of passing along those tools and those resources. But are you in a Docker Swarm? I am not. We are going to do some Docker Swarm. I don't use Docker Swarm. I use Docker Compose, and then besides Docker Compose, anytime you're in an enterprise environment, Swarms not really the go-to tool there. There's Amazon's ECS, there's Kubernetes, some other options for that. There's Rancher. So I know Swarm. I don't really use Swarm though. Yeah, and I'm relatively new to Kubernetes as well. Kubernetes is it's big. I know a lot about Amazon's ECS though, but I know a lot about Compose. But yeah, I'm getting much deeper into Kubernetes though. Kubernetes is it's what's paying right now. We do want to learn this stuff. We do want to be great at this stuff, but we want to be great at it because money does matter. And right now, the industry, Kubernetes is very in demand, and people are paying a lot of money. They're paying a lot of money for people to know Kubernetes, which is very interesting. So make sure you pay attention when we get to the container part because Kubernetes is definitely great. The production Docker without going all in on. Yeah. Oh, so I don't know. Are you on any cloud provider? If you want to go all in on Docker, again, that is one of the reasons why ECS is not perfect. Amazon's ECS isn't perfect. ECS stands for Elastic Container Service. It's not perfect, but it's great when you need more orchestration. We need more orchestration than Docker Compose, but not quite as much as Kubernetes. ECS is kind of perfect for stuff like that. K3S, I don't even know what K3S is, but that sounds good. It sounds like it's easier than K8S. But yeah, we'll talk about that. It's great, but so complicated on bare metal. Yeah, yes. So, if you do need to do it on bare metal, check out Kubernetes the hard way. That'll let you know how to spin it up all from scratch. Pretty tough process, pretty intricate, tough process for sure. All right, so we got Terraform downloaded. Let's get into writing some Terraform code. So what's the next section we've got here? Let's go next to build infrastructure. They're hopping straight into it. No, they're not playing any games. They want to hop straight into building infrastructure. So what are we doing here? Actually, let me full screen this and let's go down. Let's move this down one. All right, so that's a little bit easier to kind of follow where we're at. My terminal is just below our instructions. Oh no! I love it. They're not interruptions. They're good. It's good sidetracking that happens, in a classroom setting. I really like that. I like that the banter. And again, if we ever go off on tangents and you have no idea what we're talking about, that is a good thing. Just listen to the conversation. Maybe write down the things that you're hearing that you have no idea what we're talking about. And again, go Google them afterwards, watch a YouTube video or two on them, get comfortable hearing people talk about technology, get comfortable, engaging in it and listening to it. And I'm telling you, you'll really start to pick this stuff up. You'll be able to get conversational about it. It'll really help you in interviews as well. So if we start talking about things you don't understand, don't sweat it. Again, pay attention, write down the things you're not too sure about, and ask questions. Say, hey, you said this, like you were talking about this thing. Maybe later on you can explain it to me, or something like that. Like, definitely don't be afraid of the things that we are talking about. And feel free to get into the conversation too, even if you don't know much. If you think you have some good input, feel free to hop into those conversations. All right, so now we want to build the infrastructure. So this is the coolest part, for sure. And we can get into it pretty fast. So with Terraform installed, let's dive right in and create some infrastructure. We'll build infrastructure on AWS. Again, a lot of people are using it to build on AWS, but you don't only need to build on AWS, and we'll get to there shortly. But it's popular. They're saying AWS is popular, so they want to use it there. But you can manage many providers. Actually, we got into it earlier than I thought. So let's take a look at these mini providers that we're talking about here. So we get into the providers, and Terraform is used to create, manage, and update infrastructure resources such as physical machines, VMs, a lot of stuff. But these are all the options you have. So, we have Azure. We have all these things that Akamai is great. That's a big CDN. We talked about content delivery networks. Akamai does the same thing that CloudFront does, and Amazon Web Services. But it's bigger. It's better. To be honest, it costs a lot more too. So a lot of different things in here. We see Amazon, AWS here, Azure here. I think we saw Google Cloud Platform up here, but it's more than just cloud providers. It's different cloud resources that you can spin up. So again, you can spin up stuff with Kubernetes, Chef as well. So you can actually use Terraform to kind of manage Chef resources, which is great. But there's a lot of options in here. So if you're not sure, if you're using certain things, definitely take some time and check out this list. And these are just the official providers that they have up. But they also have a community providers page where other people in the community can go ahead and build out the ability to work with other providers. So again, things like 1Password and all this other stuff. So it's pretty great. So check that out when you get a chance. Actually, how do I go back when I'm full screen? We'll go back here and we'll close to the right. And we'll go back again. All right, so we saw all the providers. So now we know that we can build on multiple platforms, multiple services, and that you can have multiple providers in a single configuration. So great. Definitely check out after tonight, after we run through this, please take a look at this use cases section so that you'll understand how to use it, but I want you to understand why you're using it. So we talked about that a little bit before, but these use cases might help you. They might not. Like, you still might have a couple layers of things to kind of get caught up on and a few concepts to understand. But read through this and see if you can start to understand why you might use it. And again, these will be great talking points for interviews. Like, if you kind of read through these and just understand them as best you can, and learn to be able to talk through things like this, you will be great. You'll be good to go. So definitely take some time after this and go to the use cases section. So we've previously set up AWS accounts. If you don't have one, feel free to go ahead and set up an AWS account. I'm not going to stop now to do an AWS account, but I will actually take this time. If you want to go get set up on AWS, I will take some time to get logged into AWS. And where's my phone at? Authentication. All right, so I'm in my Amazon Web Services account. Actually, I'm gonna go 1 second. I don't know why every time a song comes on, even though I like it, every time a song comes on with anyone singing or talking, it throws me all the way off. Like, I think it's because I'm kind of listening to myself speak and I hear other words. Like, it really throws me off every time. So I'll probably skip a song every time it comes up and it's got words in it, to be honest. Really weird. I gotta get over that. I'll figure that out. Go React.js. I am not going to KubeCon this year. I do plan on going to KubeCon next year. I'm going to a few other conferences this year, which has kind of depleted the job that I work at. We have a professional development budget, and I've kind of depleted that. I am going to Amazon AWS reInvent again this year, and I'm going there specifically to learn, but to also take the Solutions Architect Pro exam. I kind of like taking the exam there. I like the high stakes. It feels cool, you know, on that high level to be able to take these exams. It's a pretty tough test, so I'm going to be taking it there. So I am going there this year, for sure. Instrumental only lo-fi beats. So that's basically what I have. I'm running a Twitch and Chill playlist, which is basically all free lo-fi stuff that that's not copyright, that's copyright free, so that I can upload it to YouTube so I don't get copyright striked on YouTube. And 99% of these have no words, but 1% does, and it throws me off every time I hit one, every single time. And so I do have some other lo-fi playlists, but those videos are actually getting copyright striked. So I had to do some finagling. So I make sure to use the 2 or 3 playlists I have that don't have any copyright written music on there. All right, cool. So Amazon Web Services, we're in our console now. And so just remember, like, what we're going to do with the example is we're going to spin up an EC2 instance to start, and we'll do more than that. But remember how we did it last time. Remember what it's like to spin up EC2 instance. It's not hard, but we launched it. And again, it will be hard for you to replicate exactly what I did unless you were watching and I told you. What we went through when we had to click a bunch of stuff and configure a bunch of stuff. We're going to learn how to do that through code now. So let's go back, and we don't have an AWS account, set one up. Cool. So configuration, to set up the set of files used to describe infrastructure in Terraform is simply known as Terraform configuration. We're going to write our first configuration now to launch a single AWS EC2 instance. So you've come a long way. If you know what this line means right here, you've come a long way. You know more than most of the population about this stuff. So we're going to write our first configuration. We're going to write some configuration to launch a single AWS EC2 instance. You know, there's a lot of letters in there. So if you know what an EC2 instance is, you know what AWS is, you've come a long way, and you should be proud of that. So that's what we're going to do. The format of the configuration files is documented here. And so we'll talk about that in a second. And then configuration files can also be JSON, but we recommend only using JSON when the configuration is generated by machine. Let's talk about this. Let's break down this line. So whereas you have a programming language like Ruby or Java, things like that, a lot of tools like this, provisioning tools, infrastructure provisioning tools, configuration management tools, have something called their own DSL, which is domain specific language. And so that's basically, it's not a normal programming language that you're familiar with. It is a custom way they've kind of set up the configuration that you write for the application to be able to accept. And the goal is basically to write it in a way that is easy to consume. And also it's a way to go ahead and be able to easily structure the language per se. I don't really want to call it a language, but it's a language. Don't worry, don't let that confuse you. Don't let that think you've got to remember how to write all this new stuff. Not so much at all. But yeah, this is just a guide to let you know how kind of the language works and how things kind of need to be set up. We can get most of that through the examples that we have here, but you can read through that if you want to learn some of that stuff. All right. So they said the configuration files can also be JSON. So we talked about JSON, and if anyone remembers in the serverless lab, every time we hit an endpoint, we were getting a JSON response, and that JSON response was basically key value pair. So it was like name Aaron, like last name Brooks, and it was like message, and then equals the long message that we had. So and it's got it's got curly braces as well. This is not JSON, but it's got a lot of curly braces, and it's a little bit hard to read. And again, let's actually type in JSON example. So this is JSON right here. You can see here how it's very hard to read, not human readable, but it is easily generated by machines. And so it's a good way, if your machine is generating something to generate in JSON to be reused elsewhere. So they're saying that's the only time that you should use it, but you can write it in JSON if you want. You never want to write it in JSON, trust me. So that also kind of tells you that whatever we're writing it in is probably JSON compatible, or that it gets boiled down into JSON eventually. But yes, you can use JSON if you'd like. You should not. All right, the entire configuration is shown below. We'll go over each part after. Save the contents to a file named example.tf. Verify that there are no other TF files here. So if you've never seen this before, star is a wildcard. So that means anything. So it's basically just saying there are no other files that are of the type TF or the extension TF in your directory, since Terraform loads them all. So if you ever see a star, you can use a star as a placeholder for anything, which is really nice. And you'll have to use wildcards like this a lot of times throughout your career. So it's important to know what the star is. So it's basically saying anything.tf, make sure that doesn't exist in your folder. And so let's do exactly what they said. So they said to talk about each part after, but let's go ahead and do that. So we'll copy and paste this. And they're saying, save it to a file named example.tf. Now, I am going to go back to my shell. Let's clear it. I'm going to actually remove this Terraform binary from here to clean this up. All right, that's gone. And if I still type in Terraform, it still works. So everything's set up properly. How do we create, let's incorporate some Linux commands into this instead of going right into it. Let's go ahead and how do we create let's create an empty file first. You don't need to do this, but we're practicing. To create an empty file in Linux, you type in touch or Mac, type in touch, and they said example.tf. So we'll follow their exact example for now, and then we'll diverge a little bit later. So we're gonna touch example.tf and take a look at what's in our directory. I'm gonna start to try to remember to start typing in ls instead of ll. ll I have is just an alias, and it's not available on everyone's system. So people who are following along have like messaged me like, hey, when I type in ll, nothing works, and it's like, I'm sorry. Mine is just an alias for ls-lah because I don't want to type that in every time. But we've created an empty file here called example.tf, and there should be nothing in it. 0 bytes, perfect. We did the first thing they said. So save the contents of a file named example.tf. So I think I copied this. I'll go ahead and copy again. Let's go ahead and save the contents of this. So if you're watching, okay, so actually I'm gonna open this up in VS Code first. So most of you are probably using Visual Studio Code because that's what we installed earlier in the course. VS Code is excellent. I think you should use it. I am probably going to use Vim for all of the infrastructure as code section. Yeah, I'm probably going to use Vim for all the infrastructure as code section. But if you wanted to open up VS Code, that's how you can do it. Basically, we just need to open up a text editor, and we need to edit this file. So all we're doing is putting some text inside of a file. So any way that you want to do that, you're more than welcome to do that. If you're using Atom, if you're using Notepad++, if you're using Notepad, you can use all of these things to edit a file. You can probably even use Microsoft Word if it lets you save the .tf extension. But yes, you could go ahead and use anything that you want. But we're going to use Vim here. We're going to stay in the console. We're going to stay in the terminal for as much as we can. So I'm going to clear this, and I'm going to go ahead and edit this file. So we're going to use Vim, and we're going to Vim example.tf. And again, my Vim probably looks a little bit different than yours because I have some changes, and you can actually grab my Vim settings if you want from my GitHub. I think if you just type in !Vim settings, you can grab those. One day we'll definitely talk about how to get your computer set up to kind of look like mine because it's not easy to do that out of the box. But let's go ahead first, and let's go ahead and paste in what we had. So, I just copy and pasted. And we have exactly what they have here. And maybe before they even break it down for us, maybe let's go through and see if we can break it down ourselves. So 2 things here. We've got a provider here. It says provider AWS. So we talked about providers, which is kind of the platform or resource that we want to use, the platform that we want to use. AWS, that makes sense. So we're letting them know that we're using AWS as opposed to maybe something like Azure. So we're letting them know that we're using AWS. So great, pretty simple. And then a profile. So I don't necessarily think we talked about profile with Amazon Web Services, but you have seen me set up my credentials. So I have some credentials set up locally, and I don't want to accidentally show my credentials, but your default credentials, once you set up credentials by default, if you don't change anything, it is your default profile. But you can actually set up multiple profiles. So let's say I had 3 or 4 different Amazon accounts. Maybe I had my one personal one, and I also had one for work, and I also had one for my business. I would basically, you know, how do you manage 3 different sets of credentials on your computer? You'll basically set up 3 different what are called profiles with your keys and stuff in there. And again, I don't want to show you actually, let's Google what that looks like. I need to figure out a way to blur certain sections. But AWS credentials file. I want to see if I can find an image of one setup, because I think when I go into when you click on the Amazon one, it doesn't exactly show you what's in there. Cool. So yeah, so by default, when you run that AWS configure command, you set it up like this, and this is what happens by default. You plug in your access key ID and your secret key right here. But if you have more than one account, you can set this up again, and like you just change the name right here. So I would copy and paste this basically underneath, and actually let's show you an example file. Let's copy this. Let's do something. Let's save this, and let's vim test credentials.txt. And so I'll paste what we just had in. And so to have multiple profiles, basically you basically have different keys here. So it says example 2, 3. All these will be different. All these credentials will be different down here. But basically in here, I will set this equal to work. And I will set this equal to business. They can be called whatever you want to call them. Business. And this is how you can manage multiple authentication keys from the command line. So, you know, you normally have to if you're logging into the console, you know, you can log in and log out, but how do you manage it from the command line? It's like this. And all you'd have to do to use them is I would run something like AWS S3 ls -- profile equals, and then I'll say like work. I'll tell it which profile to use, and it will use that to authenticate the command and run that command. So if you're all set up, that part was important for that second line. So if we're gonna vim example.tf, that's important here. So if you want to use a different profile other than default, you need to specify that here. So if you needed to use work, you'd have to specify here and tell it which credentials to use. So we'll leave that to default. And then the region, we talked about regions, and that's going to be US East 1. And then the resource. So we talked about provisioners spinning up resources, and basically all we're doing here is we're spinning up an AWS instance, and it's called example here, but this is actually not the name that AWS is going to give to it. This is so that Terraform can reference it. So we can call it whatever you want. We'll call it Mastermind. And then AMI, so this is the ID that it gets built off of. And so we're actually going to change that, and then the size of it. So you have way more options than this, but we'll start out with this stuff at first. And so I went over a lot with the AWS profile thing. So does anyone have any questions about that? Do we have to switch from VS? No, you do not have to use VI or Vim at all. In fact, I don't think you should. I don't think you should switch if you've never used it before at all. You should be using VS Code for this. Type in and save. Don't sweat it. Don't sweat it at all. Especially if you're following along directly. I might try out V if you're planning on doing this, you know, on your own later. But I would use VS Code for this. Learning curve is very high compared to VS Code. VS Code also has way more tools available to it. Maybe I'll do them side by side as way more tools. I'll show you some of the cool tools as we get into it, because things like VS Code have Terraform plugins. So if you go into extensions in VS Code, you can type in Terraform, and you can go ahead and install syntax highlighting. And there's some other ones that you may need or that you may want to use in there. But so then once you hit into this, you get some cool syntax highlighting. So you can see here, this looks way better. And if I were to start typing, like let's say I wanted another resource, it would automatically fill that stuff in for me. So VS Code is really, really nice. And then I can type in something like this. Again, it's really easy to use, and I would use VS Code. But the only reason I'm going to use Vim, VI or Vim for the infrastructure as code piece is one, to for people to not be like, I'm hoping the exposure to it will help a little bit. I'll talk through some of the commands that I'm running, and I'm actually gonna see if I can get a little key logger to pop up like in the corner or something so that you can see what keys I'm typing. But I do want to encourage people to, again, not switch to it, but take some time to try it out in the future, because there will be times when you can only work on a server that has VI or Vim. I've seen that more times than I thought I would, where people were required to edit these manifests, edit these templates and things on an external server that only had VI or Vim. So yeah, VS Code is super nice. Definitely download it. Definitely check it out. All right. So we have this here, the AMI ID. So we're gonna change this. I don't know if their AMI is currently up to date. I'm gonna show you where to go to get an AMI, and we're gonna deploy the AMI that we want. So let's actually go back into this. There's other ways to get this. There's lists online that you can use to get AMI IDs. Amazon has them. But one of the easier ways to get it, let's say you spun up your web server and you set it up manually, and now you want to codify it. Now you want to write it in Terraform, and you want to say, hey, I want to go through, and actually I used Ubuntu server for this. I can grab the AMI right here. So it is very important. I don't think we ever talked about this. These AMI IDs, they are specific to a region. So this same Ubuntu server AMI is actually, let's copy this down. Let's paste this somewhere. Let's paste it right in VS Code, just to show you. So now you're learning some more about Amazon Web Services. So this is US East 1. If I go and look at the Ubuntu AMI over in Asia Pacific, come on, taking forever. And I go, and oh, it took me straight here, which is perfect. But you can see here, I copy and paste this. This AMI ID is completely different. And this is for Asia Pacific. I don't know what that, I don't know what that actually is. Oh wait, actually did I paste the same thing? Or are they, they're not copy? Copy. They are different though. Okay, yeah, so they are actually different, and that's very important. So if I said that my region was US East 1, but I went and looked and I actually grabbed this Asia Pacific AMI, it will fail, and that is a problem that a lot of people run into. And so I want to make sure people know that AMI IDs, even for the same image, are different in every region. And again, that's because they need to get copied around. They can't get served from the same place because of the way regions are set up. So it is very important that you grab the right AMI ID for your region. So we're gonna go ahead, we're gonna copy and paste this, just so that we wanna make sure that we're getting an Ubuntu server. So we're gonna paste this in here. And so it's gonna build off of that. And then instance type, leave it at T2 micro because that is the free version. And actually, you know what? I'm gonna get out of Vim, because save that. Oh, no, I don't want to save this. I just want to get out, quit. No, I don't want to. What's happening? Okay, enter, cool. This is why Vim is stupid. Let's get out of here. And let's go back into VS Code. And I forgot VS Code has a terminal in it. So we can do everything from one place. So we can hop into VS Code. All right. So we have our file here. We gave it the right AMI and instance type T2 micro because this is the free tier. All right, so we copied and pasted what they said. We made our own modifications. I'm assuming that the one they have in there will probably work fine, but we're not gonna leave it up to chance. And I just want to show you that you can choose what gets spun up. And it says verify there are no other star.tf files in your directory. So are there? There are not, but we're gonna go ahead and remove this test credentials file. All right, this is the only thing we have in here. All right, so, oh, okay, actually, I didn't even know they had this noted here, but it tells you exactly what we just talked about, that the AMI matters, and that you will need to grab one that's specific for the region if you want to change it. And it also talks about the profile that I talked about, and lets you know how to set up your AWS profile if you need to, but for time reasons, we are going to go ahead and we're going to skip that part. This is a complete configuration and the Terraform is ready to apply. The general structure should be intuitive and straightforward. Again, it's pretty straightforward, not too difficult, pretty simple, simple way to set this up. So it explains a little bit more about what we went through, and then it talks about how to initialize this. So the first command you need to run for a brand new configuration is the first time we're running this configuration brand new. We need to run Terraform init. So let's go ahead and run Terraform init. And Terraform init is going to go through and make sure all your dependencies and everything are caught up for this configuration. It's going to run through. It's going to let you know, hey, everything has been initialized successfully, and you're all good to go. And so we run that. And now what are we going to do next? Let's just know a little bit more about initialization. Again, definitely go through and after we run through this, like, make sense of what we're doing first, and then go back, I think, and read this stuff, and it might make a little bit more sense about, so you can know exactly what Terraform init does. But again, it's the first thing you need to do if you ever start a new configuration or you download someone's configuration. You need to run init first. And then we're going to go ahead and apply our changes. So again, they have a note here that lets us know that the commands shown are for version 0.11 and above. And again, version 0.12 and above is different from everything below it. So that is important. These notes are important. You used to have to run this Terraform plan and then Terraform apply. But now, as long as you're in the same directory as example.tf, file you created, you can run Terraform apply and look for the output below. So we're just gonna, we don't really know what we're doing. We're gonna go ahead and run exactly what they said. They said run Terraform apply, and we will do that. All right, and they said we would get some. They said we would get some output. Yeah, they said we would get some output, and our output does look similar to what they said. Let's take a look. Run Terraform apply, and then it'll let us know this stuff. Does ours look like that? Absolutely it does. And let's take a look at what it has in here. An execution plan has been generated and is shown below. Resources actions are indicated with the following symbols: create. So basically what you're looking at is it's telling you exactly what's going to happen if you were to run this code. So you ran apply, it basically runs through and it checks what changes it's going to make, and it lets you know what changes it's going to make. So basically it's letting us know an AWS instance called .example will be created, and actually we're gonna change the name of that real quick, so I'm not gonna run this. And it's letting us know that it's going to add all of these things. So these are basically all the things that are going to that AWS is actually going to provide to the EC2 instance. And again, Terraform's not going to know what any of these things are until after it provisions it. So it won't know, like the IP address, it won't know until after Amazon provisions it and gives that back to Terraform. Yeah, so it lets us know everything that's going to be changed. And so you want to look for pluses. Pluses mean something is going to get added, and a minus means they're going to get taken away. Actually, it might be a tilde for that, but yeah, there's another symbol for when you're going to remove something. And lets us know here, this line is important, that we're going to make one addition. We're not going to change anything, and we're not going to destroy anything. That's very important. You want to look over this plan and make sure it's what you want to do. So I don't want this, so I'm going to control C out of it because I want to call this mastermind instead of example. So basically, again, this name right here is only for the resource in Terraform. So as far as Terraform is concerned, this AWS instance, this Ubuntu AWS instance is called mastermind, and we can refer to it as such. So let's run that Terraform apply again. It's going to give me the same information because it actually hasn't done anything yet. Lets me know it's going to be called mastermind. And it says, hey, if you want this stuff to happen, go ahead and type in a value. Only yes will be accepted. And I'll type in yes and check this out. My backend, let's go back to US East. Let's go to EC2 dashboard. And going slow. Let's see what's happening. It's going through, and already it's provisioned this for us, but my AC2 dashboard's going slow. Hopefully this isn't shutting down. All right, so 2 running instances. All right, and so this is still initializing, but it would have shown you when this was coming up real time. But this is the server that we just deployed with Terraform. So Terraform was able to use my credentials for AWS locally, my default profile, and go ahead and spin us up a server. So you can see here how there's no name here, even though we called it Mastermind. Again, that name only refers to how Terraform is able to see and check out these things, but it's initializing, and yeah, it's able to spin that up. So we can check out the AMI down here. We can find in here what AMI we're using, and here's the AMI right here. It ends in 8EF8. Is that what we specified? Yes, we specified this. So you can see that it's a T2 micro right here, and so perfect. We basically wrote a file. We wrote code. We basically ran it through this tool, which contacted Amazon, let Amazon's APIs know exactly what we wanted, and it went ahead and it provisioned that infrastructure for us, which is great. Yeah, so I'll let you try to, if anyone's trying to run that, I'll let you try to run that. I'll get caught up on some of these questions. So, is there actual difference between the 2 images other than meta concerns like availability regions? No, yeah, they're just stored in different places. They're stored in different places and therefore get different tags and meta concerns. Yeah, the images are the same. Name location differences. Our images already figured. If you create custom AMIs, they'll be in a specific region. That's usually when it really makes a difference. Not configured. If you were to hash the image from US 1 East to Asia Pacific, it should be the same. Theoretically, it should be the same. I don't know if Amazon does anything weird, like again for like the Asian markets where certain things aren't allowed. I'm pretty sure they are not. They're not sanitized that way. They should be the same if you ran a hash against them across regions. It just hit me with the usage limit because my instances will stop and not terminated. Keep your eyes open for him. Absolutely. If that happens to you, if you hit any of your limits or anything like that, for sure, reach out to Amazon, send a message to their support, say, hey, I'm trying to learn Amazon. I was doing some labs, doing some testing. You can actually send them a link to the Academy website. Let them know that's what you were following. They should give you your money back or credit, or not even make you pay it before you pay the bill. Go ahead and send them that message. They'll usually remove all those charges for you for sure. Make sure provision server being fully configured too. Yeah, and 10 servers at once with a single command. Exactly. Like we've done a very small piece here, but imagine I wanted to spin up 10 servers, and you saw how fast I did it. I before I could even reload the page, a server was already up and running, which is great. And so we're gonna add more configuration options, but at its core, this is all you need. You don't really need much more than that. This is all you need, and it'll spin you up something. Now we can add more. We can configure everything that's here. You can configure everything that's here basically. So if I want to give it a name, tags, or any of that stuff, I can pretty much configure all this stuff. And we can get into that shortly, but it's pretty simple. And again, imagine if you're going to do that at scale. Imagine if you want 10 servers. Imagine if you want to set up, all kinds of resources. It's really simple to do this way. All right, cool. Let's move on to what's next on their list. So we applied our changes, lets us know everything was good, and then it's just showing you everything we've already gone to. So now we're going to change the infrastructure. So what happens when you want to make changes? We spun up this infrastructure. What do you do when you want to make changes to it? So let's look through. It says, let's modify the AMI of our instance with AWS instance.example. And they want us to go ahead and change that. So there are a few things that happen. There are 2 different types of changes. And actually, maybe I'll talk about it below, but 2 different types of changes. If you change something like the AMI, so it's again, remember, AMI is the image that the server is deployed off of. So we used Ubuntu, and they said, we want to go ahead and change the AMI. So maybe they want to change it to something like Amazon Linux. You can't just change the AMI because the machine was deployed off of that. So you can just change it. You can change it as far as Terraform is concerned. But then how does how does Terraform and how does Amazon handle a change like that? Basically what it does is it spins you up another server with the AMI that you want, and it removes the other server. So we can do, actually, let's do that. Let's go ahead and let's grab a new AMI. So let's grab the Amazon Linux AMI, and we'll grab this. And this is important. Like, let's say you're on why would you want to do something like this? Maybe your company is using, and this actually happened on our project, we were using CentOS, which is the open source version of Red Hat, and we're using CentOS for a while, and that was all good. And then one day some requirements came through that said, hey, for certain reasons, security reasons, for a lot of other things, we now have purchased Red Hat licenses. We need to switch to Red Hat, which is a drop-in replacement, basically, but we know you got to do something like that. And for you to be able to change 30 servers over to Red Hat used to be a hassle. You'd have to re-provision everything. You'd have to do all this stuff. Now you kind of just go in. I changed the AMI ID, and if I'm ready to make a change, let's clear this out. We run simply a Terraform apply again. And now this will be good because we'll get to take a look at what a change looks like. All right, now we see minuses and tildes and all kinds of stuff. This is great. So it lets you know exactly what's happening here. It's saying that AWS instance.mastermind, you made a change to the configuration. You made a change to what you said it was supposed to be. And for me to make those changes, I can't do them in place. So I'm going to have to replace this. So this must be replacement. And it lets you know this is what changed. And this forces a replacement, so that it's got to be replaced. And it gives you a lot of information. So these are all things that are going to change. These are things that are going to be deleted. So plus and minuses is going to be deleted. Everything else is going to be changed. The minuses and things like that are going to be deleted. And what's going to be added back. So look through, make sure you understand what's going to happen. Again, it's important to see what is in the plan here, what's going to happen. Not only is it going to add new resources, it's going to remove a resource as well. So it's going to add one, and it's going to destroy one. And that's what a replace is. Add one, delete one. And so some changes require this. And that's, again, something like an AMI change that must be done. So we're gonna type in yes. And then very quickly, we're gonna go back and see what happens, because I actually don't know what order Terraform does this in. I know what order CloudFormation does it in. And it looks like Terraform does it in the order that I don't like. But I'm sure there were some ways around this. I know there are ways around this. There are definitely ways around this, but it looks like it's deleting first. You can make this change so that it spins up your other one first, especially if you're throwing it into an auto scaling group. We didn't talk about this, and maybe while this is going, because this will take a little bit of time, it's gonna shut down that instance, spin up the new one. Let's talk a little bit about, and this will become important when we get to Ansible. This stuff, configuration, infrastructure as code, configuration as code, is either, most of the time we're going to talk about, is either going to be imperative or explicit or declarative. So imperative means I don't have to necessarily tell it exactly what to do. It kind of goes through and it's able to, you can kind of write it in any order, and it mostly understands the rules and things like that, and it'll go ahead and set some things up for you. But then there are some times where you don't want it to be imperative. You need to be explicit, and you need to tell it exactly what you want to be done. And we're going to get into some of that a little bit later with depends on and things like that. If you have certain resources that need another resource and can't be used until that happens, there's some explicit or declarative things that you can throw in here a little bit later. But yes. Can each one of those blocks and options in the apply output be set manually in the TF file? Oh, all these, yes, just about everything in here. I don't think everything for EC2 instances, and we'll go through and look at the EC2 instance docs to see what we can actually set. But yes, just about every single one of these things can be set in here. Well, not just about a lot of them can be set here for sure. Some of them, because of the way Amazon configures things, can't be set, but yes. Most of these can be set and configured inside of here. Wanted to turn one up before turning the other one down. Yeah, exactly. But we're just running through the example right now. So I terminated one, and it's still running, still creation complete. Let's see here. I don't see, oh yeah, it did. I need to do a little refresh. I was like, I don't think it did what I wanted, but you can see here, it is running an instance. Cool. So that's what a change like that looks like. And let me see if they give you another example. So we applied the changes and cool. So let's actually take a look before we move on to destroying infrastructure. Let's take a look at what an in-place command looks like. So actually let's do something like this. So let's say I wanted to figure out what options I had available to me for an EC2 instance. You can Google something like this, Terraform EC2. You can just simply do that, and then it'll take you to AWS instance, and that's what we're currently using. And it tells us how to use it. So there's some Terraform documentation here. We are in the docs, we're in the providers, that is AWS, and we're figuring out how to use an instance. So there's an example here, and let's say I wanted to set a name, and very quickly, just running through, I know that a name in AWS is actually just a tag. Like that's all a name is in here. And so what if we wanted to set a tag for that? Looks like this example has it here, but you could also look below, and these are all the things that you can set. All of this stuff are things you can set. So just about everything you saw you can set, but I want to set a tag. So I can just copy and paste this. And it looks like the way it's set up, it's kind of right in line with everything else. So let's copy exactly what they did and let's paste it in. And we want this to be called Mastermind Terraform. All right, and that's the tag, that's the name tag that we would like on this file. Let's save the file and let's go ahead and run this so that you can see the difference. All right, so it's gonna run through. Take a look at what we have here. So one, it lets us know that something needs to be updated, but it lets us know as opposed to being replaced, where everything was in bold and all red up on the last one. It lets us know that this upgrade or this update can be done in place, which means you don't have to delete any infrastructure and it can be changed right in place. It lets us know that the resource AWS Mastermind instance will be changed, and the exact thing that will be changed is the tag. So we'll be adding this name tag right here. It lets us know that nothing will be added, one thing will be changed, nothing will be destroyed. So what does an in-place upgrade look like? Run super quick. You see, just like that, it ran. And if we go back and check this out now and refresh, awesome. Just like that, we've been able to add a tag to our Amazon resource. You can see how, again, now this is a great way for us to be able to go through and manage our infrastructure. We very easily went through and managed that infrastructure. I didn't have to do a lot there. We can make changes to it if there were more things that we missed. If we wanted to add more tags, if we wanted to change the size of the EBS, maybe we, instead of 80 gigs, we wanted 200 gigs or something like that. These are all things that we could define in code. We write code and we tell Amazon basically what we want out of that code. Did I move this all the way? Yeah, too high. Yeah, cool. So this is, again, and so I could actually, just so you can see, I'll copy and paste this. And I'll call this one Mastermind Another. If I was gonna run two of them. Same thing, I could make this a different AMI if I wanted. And maybe I want this name to actually be Mastermind number 1. And maybe I want this one to be Mastermind Terraform number 2. And I save it, and I run through, and I do it again. Goes through and it lets me know what it's gonna add. It's gonna add all this stuff, but it's also gonna make changes to this one. And I'm gonna just say yes, looks good to me. And just like that, I've changed my first server. I made changes to my first server. Well, those are probably gonna get changed after this. Oh no, it made changes and this one is spinning up. So just like that, now I have 2 servers, which is great. So you don't need to make a new file. You just throw in another resource. The resources are what are important, and you can just throw those underneath. So I could also do something like, I'm not gonna add it, but like let's say I wanted an S3 bucket. So I will go down in here and I'll find out how to do an S3 bucket. And you know, if I want an S3 bucket, I can just do something like this. And now we're moving. We're creating all kinds of Amazon resources. This will create me an AWS S3 bucket, and I can call it whatever I wanted. But yeah, so you just use the documentation and follow it along and create these real tangible resources. We're not gonna do anything with that. Now that we have 2 servers up, we are good to go. But again, you can use the same paradigm to spin up any type of infrastructure that you want to. Cool. Next thing. Let's learn how to destroy infrastructure. So it's important, creating infrastructure is one thing, but destroying it's a whole nother thing, and that's something that you need to do. Cloud infrastructure has been kind of one of the benefits of it is you can build it up, tear it down. So what happens if you want to destroy infrastructure? So let's actually say you're working on an application and you set up some Terraform to spin up. Maybe you actually have a very complex network of AWS resources that you need to run your application. You can spin them up for a few hours. You can spin them up, push one button, write your Terraform templates, press a button, get them all spun up, start developing your app and testing your app and running your app for 5 hours. And then so that you don't have to pay for those resources, you can go ahead and destroy all those things, which is pretty simple. And again, it's not overly complex. All you got to do is type in Terraform destroy, which is really great. It says it, it works similar to Terraform apply, but it behaves as if all resources have been removed from the configuration. So really easy. We'll go ahead and do Terraform destroy. Now, for what we've created, we don't really have to worry about this too much because we don't have anything saved on here. It lets us know that it's going to delete all this stuff. You see all the minuses, can delete everything. Now, be careful with this. You don't, so when it comes to things that need to persist data and things like that, you don't want to delete those things. I mean, there are ways to flag things so that they're not deleted, and there's other ways to handle that. But when you are using the destroy command, be careful. So things like databases, let's say you're trying to, maybe you had a WordPress instance or something, and you were using Terraform to manage it, and you spun up an RDS instance, and your database is running on there. You probably don't want to destroy that, or unless you have some type of backup plan or snapshot or something like that. So be careful with that. Again, with things that have persistent storage and things that you need to keep data around for. But destroy, if you want to destroy any infrastructure, you can easily destroy it. It basically references everything that the destroy command will reference all of the things all of the resources that you've spun up using Terraform. So let's say I had other servers. Actually, I do have another server in here that's not being touched. So I have this default VPC server that I need to delete, but it's not being touched by anything that I'm doing. When I ran that destroy command, everything got terminated except for this default VPC server, because I did not use that. I did not use Terraform. Sorry about that. I did not use Terraform to provision this server. So it doesn't mess with that server, which is really nice. Which is really nice. Test the app. Test it in I mean, yeah, I as you become more confident in your CI/CD pipelines and more you get more confident in your feedback loops. Hey, I mean, testing in production isn't always so bad if you can get out changes pretty quick. Sometimes it can be cheaper, and if it's not super high stakes, if you have a relatively low stakes project or application, go ahead, feel free to test in production. I guess I shouldn't encourage that, but I mean, hey, if you're confident in it, go ahead and do what you need to do. It's a common paradigm for sure. Most people test in production and won't admit it. I think when our test engineer on our team posted something about that the other day, which is pretty interesting. All right. So we've destroyed our infrastructure. Excellent. We're not really worried about it because we can reprovision it at the push of a button if we'd like. So destroy, very short pieces here. And then I'm gonna make this a little bit smaller. Resource dependency. So we talked about this a little bit, and we can go ahead and add this really quick. But what are resource dependencies? This is when you have a configuration that depends on some other resource or configuration. And how are we going to use this? So up to this point, our example has only contained a single resource, except for ours. We added 2 resources a little bit early. But yeah, real infrastructure has a diverse set of resources and resource types. Terraform configurations can contain multiple resources, multiple resource types, and these types can even span multiple providers. A lot of words, a lot of jargon. This just means that sometimes you're going to use a lot of different resources from a lot of different places, and sometimes some are going to depend on other ones. And this is going to tell you how you do multiple resources and how you reference those things. So one of the resources that we're going to use is an elastic IP, and we'll talk about that in a second. It says we'll improve on this on the current thing that we have set up by adding this resource. So we'll copy and paste this, and we'll talk about what an elastic IP is. All right, a little bit lower. I'm gonna paste this right underneath, and we're gonna change this in a second. And this underlining is actually what's great about VS Code. But paste it in. What is an elastic IP? So every time you spin up an instance, and all these had it, but it went away right here. Every time you spin up an instance, it gives you a, it assigns you a default IP address and a DNS address. So yeah, these are just dynamically assigned, just any IP address, any public DNS address. But what happens if this server is the one that's running your website? And again, we talked about DNS, and that's how, you know, the internet works and how a computer knows where to go to get your website. You don't want that to change at all, actually. So what you do is you assign these things called elastic IP addresses. So basically, this is a permanent IP address that you get from Amazon. You pay for it. I think they're all $1. I think they're $1 each per month. And you purchase this IP address basically, and you attach that to your server instead. So instead of it getting one of these, it'll go ahead and it'll turn blue basically, and down here it'll add an elastic IP into your elastic IPs group, and basically it'll give it a permanent IP address that it will be able to, you know, as a server, they call it elastic because as a server will die and spin up underneath it, it can just get reattached behind it and do some cool networking in the background to make that work. But we want to go ahead and use that resource. It is its own resource. It costs its own set of money. So this resource here, you know, it's not a part of this AWS instance, even though we're combining these two things. But let's take a look at it. It says AWS EIP. We're going to call this mastermind IP. And then it's referring to an instance, and it lets us know that we have a problem. It says indent, AWS instance example ID, basically unknown token. That's because the example ID is actually, remember this used to be called example, and this is why these names matter. This resource used to be called example, but this is actually a reference to the resource. So we call this mastermind. And is that spelled right? This is mastermind ID, and then do I have everything else? Why is that still giving me grossness? This instance, mastermind. That should work because you destroyed it. Perfect. That makes sense. That makes a lot of sense. This is why I should start using VS Code to tell me cool things like that. But I'm gonna go ahead and see if I can Terraform apply this. Basically, just look at what we have here. This may look a little bit confusing to you. It's AWS underscore instance, and you can see as I highlight it, it highlights this. So the first thing here is the resource, and this is just different ways of referencing the things that you have in a file. So we have AWS instance. So this part could actually reference either one of these things. And then I'm gonna pick the actual name. So if I call this mastermind dash another, this would actually apply it to this one and not this one. And actually I can leave it just like that. And then it says ID because this is actually the ID. That's just something you kind of pick up as you're using Terraform. And thank you for throwing that. Yes, we're gonna talk about the TF state in a second, but that's great. That's great that you brought that up. So run another Terraform apply. Go ahead and see what it's gonna do. And it's gonna spin up those instances. And we'll let that run for a second. You can see here real time. These things are getting spun up at the exact same time in parallel. You know, it's not like one and the next and the next. It's all at the same time, so it's really nice. Again, that's why it's really fast. Looks like one's already up. So we can click on the first one. Now, remember, I applied this EIP. I applied it to mastermind another and not to mastermind. So it's gonna get stuck down here. Mastermind another is mastermind Terraform number 2. So let's take a look now at mastermind Terraform number 2. And it's still pending. And fresh. Cool. And just like I said, this turn, let's take a look at 1. And you see here, we've got this public DNS stuff and the public IP. And then we click here, this one's blue. And it's different, it's clickable. Because this is one of our Elastic IPs that was created. And this is a permanent IP address. And I click here, this IP address is now in my Elastic IP section, and it is attached to this instance, which is great. So usually what you would have to do is, if you're gonna do that manually, you would spin up the instance manually, you click through all the stuff, make yourself an instance, you would come all the way over here and you would click allocate new IP address, and you would create another one. And then you would have to go into that IP address and you would say actions, associate address, and then you have to find the instance that you want to attach it to, and you have to click on it, and you have to do this, click all this other stuff and be reassigned, and then you have to click associate. So a lot of clicks, like 3 different steps to do it. But instead of us having to do it that way, so actually now both of them should have an Elastic IP because I just associated one with this. Yeah. But yeah, we were able to do that real quick, just like that. And I actually don't, this didn't go away. I don't know why. And actually, TF state there. Don't know why that didn't go away. We'll figure that out later. It's probably something to do with the Terraform module. Not tripping over that, but yeah, there we go. So my VS Code is still giving the unknown token error, but it's still applied. Yep, exactly. Mine's doing the same thing. Probably it's likely an issue with the, or not an issue. We probably don't have something set up that we need to have set up with the extension, but I've never messed with the extension before, so maybe we need something like this or something. I don't know. But yeah, it still works fine. So ignore that. That would not have happened in Vim. Like if I Vim this, we're not gonna get all that weird. Whoops, this has to go. We're not gonna get all that weird stuff, and it looks good in here. And that's another reason why I like Vim. But again, it doesn't help you fight as much. A little bit harder. All right, so VS Code still going the same. I've been doing AWS the hard way for no reason. Yeah, yes, absolutely perfect. T-Rex, go tell your supervisor about that, and let them, and show them the use case. Now that you know, show them the use case and take some time. This stuff is actually, it's real. Like you can see here, like this isn't hard. This isn't rocket science, and people will pay you 1000%. People, if you know AWS and you know Terraform, people will pay you a lot of money to do it. It's and again, this is not complicated. I didn't even type this stuff. I copied and pasted it, and VS Code will give you half of it. I don't even have to type in the full word resource, and I can use the tools that I have available to me to be able to build these things. And it's just becoming familiar with them and understanding how they work together and playing with the tools and spinning up stuff and seeing what happens when you do certain things. Like that's all it is. Being familiar with the stuff it's really not all that difficult. Now it does get more difficult than this. We're gonna get into some things, variables and things like that, but it's not incredibly hard at all. 150K plus, I mean, yeah, you spend enough time, absolutely 150K plus for sure. Throwing Kubernetes, you're 150K plus for sure. But yeah, you still have to, even Amazon invest, the UI is terrible and their API is where it's at. Yeah, have to configure all the network. Yeah, so you will have to usually, generally on the job, you have to configure more things than just this. But again, once you know how to configure pieces of it, you saw how I added a tag, something like an IP address, or like some kind of block storage section. You would just refer to the docs and you would test it out, and you would basically it should give you some type of an example. It should be pretty easy to do stuff like that. So it's great, super simple. Let's see what else is there. I know they have a few more things in here for us to learn. Let's see if we can get through here. So we don't need all this stuff. Provision. Modify infrastructure. Oh yeah, so provisioners are cool. We can skip, or we can run quickly through this. So, and then I actually like what they put here. So you're now able to create and modify an infrastructure, and actually this goes against exactly my nomenclature that I actually went through in the slides, but you're now able to create and modify infrastructure. Now let's see how provisioners are used to initialize instances when they're created. So basically this is like a piece of that configuration management piece. It's not all of it at all, but it's like a piece of it. So these provisioners, you can use them to actually install the things that you need for something like a configuration management tool if you want. But it basically gives you a way to do things, to run things, and install things, to use some provisioner on startup. Again, so this could be Chef or Ansible or Puppet, or initializing these things to be able to use with those things. But it allows you to configure the server in some way when it spins up. And it actually says here, if you're using an image-based infrastructure, perhaps with images created with Packer, so we talked about that, then what you've learned so far is good enough. They can let you know that right up front, that if you're using image-based, if you're configuring all the things that need to be on your server in the image, you don't need to sweat this part at all. But you know, you can do that. And so provisioner, and I can do something like this. You basically set it up and you kind of tell it what to do. One of the provisioners you can include is local exec. And basically what that'll do is it'll run your Terraform stuff locally, and on whatever machine you're running that on, it'll run this command. So basically when I go like this command right here, what it'll do is it'll spin up this AWS resource. We know what this means. We know that this will spin up an EC2 instance. And then what this part will do, let's look at the command. So echo, we know echo is how you spit something out to the screen in Bash. And then this is just a variable reference to the public IP for so AWS underscore instance refers to this resource. .example refers to this exact resource. So now we know we're talking about this, and we want the public IP. So once it gets spun up, it'll spin out the IP address and it'll put it into this IP address.txt file. It'll do that locally to the computer running running Terraform. So if I added this in and I ran this, it will basically take the public IP and it will spit it into that file for me, which is cool. And there are a lot of other provisioners that you can use here, but we don't need to use that right now. I think variables are a little more important that we should hop into as we're running out of time. So variables are great. Variables, we learned in the programming section what variables are. Variables are basically representations of values, the little boxes basically that hold values that can change actually. And so how do you do variables? So defining variables, let's extract our region into a variable. So we're going to create another file really quick called variables.tf. And so let's go back in here. And what you can do is, so if you're using Visual Studio Code, you can kind of open this up and you can touch the file again, or in VS Code, you can just click this new file button here. Super easy, super nice, super easy. We're going to call this variables.tf. I don't know. I think Mastermind needs to create a new Slack invite. Oh man, that one expires pretty often. We are absolutely going to automate that task. Before I hop into this, let me go ahead and create a new Slack invite link. Man, we need to automate that task. We're going to write a script to do that one day for sure. Thank you for saying that. Invite people. Expires in 30 days. New link. I got it here. So let's do this. Commands. Delete. Slack. The Slack's gone. Let me re-add it. So commands. Add. Slack. All right. New Slack. If you do exclamation point Slack, you will get the proper one. Yeah, you will get the proper one. Huh, who spammed? Oh, that sucks. Well, I'll do it. That's weird. Sorry about that. I really need to go in and modify that. But yeah, we should be good for Slack. So thank you for letting me know that the Slack thing had been getting had expired. So variables, let's hop right back into variables. Let's get this done. So basically what we want to do is we want to make a variable for the region. So to create a variable, you write a little piece of code like this. And I'm not even gonna copy and paste it. I'm gonna type it out because variable, the Terraform extension here will fill this in for me. So we're gonna call this region. That's the name of the variable. And then how do we set the value? You can set a default value here. Default, what is it? Is equals touching or not touching? Equals US East -1. All right, so we've created this variable. So this would just be like the same way you see this variable here. That would just be like if we were in JavaScript or something and we typed in var region equals US. I typed in use, I'll fix that. So this is just like if we were programming and we typed in something like this. These two are the same things. They're just, you know, it's syntax. They're written in a way that Terraform can understand. Type in. All right, so let's remove this. And that's the default value, and we'll save this file. And what else does this say we need to do? This defines a region variable within your Terraform configuration. This is the default value, but it's optional, so you don't need it. You don't need to put that default value. Otherwise, if no default is set, the variable is required. Cool. Using variables in configuration. So now we've set up a variable. How do we actually use it? And it looks like provider AWS region equals var.region. So in the provider section that we have set up, it looks like we can reference a variable by typing var dot the name of variable. Remember, this variable is called region. So we're going to say var dot and the name of the variable we want to use. So up here, let's go back to our examples.tf file. And for region, instead of typing in US East 1, we're going to do var.region. And we're going to save that. And I don't like, I wish I could delete all this stuff. Now this makes sense to it, but not this, but no big deal. We'll go ahead and we'll try to Terraform apply this. Now, Terraform applying this theoretically should, if we did this properly, nothing should change. It should actually not attempt to change anything because the old value of this was actually US East 1, and because we're using a variable, it's the same thing, and theoretically, nothing should change here. Nightbot meets Shug at random. Maybe actually we may be able to work on that. It might be kind of funny, but we'll be able to. It'll only mute you for like 10 seconds. It'll let us know that it muted you, and it'll let you go again. But you can see here we ran this, and it lets us know that nothing was added, nothing was changed, nothing was destroyed, which is great. That indicates that our variable is working and that we did, we did it properly. If I change this to like US West 1. And again, this is just, that's the name of the variable. And I run Terraform apply, it should let us know like, hey, this is not gonna work. And that these things need to change. So it lets us know that 3 things are gonna be added here because I'm moving it to a new region. I don't want that to happen, but I just wanted you to see that it picks up that variable. It picks up that variable from what we were doing. So I'm gonna Control C this because I don't want that to happen and change this back to East. And so there are a lot of reasons why you would want to use this variable. So there are times when you're gonna have dynamic things that need to be created on the fly. So this variable need to change. There are gonna be times when you have multiple environments. There are gonna be times when you need to pull in the value of a variable at runtime or when your Terraform code. Some people build their Terraform code through their own pipeline. But there's a lot of reasons for you to need to use variables, and as we develop more infrastructure, we're actually going to be using Terraform more throughout this course as well. So like we've been using Linux a lot. We've been using a lot more and more AWS. We're still going to be using Terraform more after today, and so you'll start to see like real use cases of these variables and how good they are, and what you can do with them. All right, so variables. So it's funny because this was a very confusing concept to me at first, but this variables about TF file. So any TF file gets loaded, And so this variables one is for basically for it's for defining variables. So like I set up this, and although I set a default option, I'm not really setting this equal to anything. There's another file that gets created, and I think they talk about it here, that you can create, and it's a tfvars file, terraform.tfvars. And so this is where you can actually go ahead and set the value. So I set a default value, so it used that default value, but I didn't have to set a default value. Basically, I just need to basically tell Terraform that, hey, these variables are a thing and they will be used somewhere. And then I can use this tfvars file to actually set the value if I wanted to. Not important to remember, but it's not important that we run through this and do an example of this right now. But yes, there are two different things. And the first time you go through this, it does not do a good job of explaining the difference between a variables.tf and the other file will be called terraform.tfvars. And these are two different files. Now, did they not talk about state yet? We need to talk about state before we're out of time, but we're gonna talk about state for sure. What else do they have? Those variables, output variables. So I'll just talk really quick about output variables. Basically, you can have, so remember how we were going through here, and it says some things like this, like that these will be known after apply. You could basically set these as output variables, and it will basically, after it gets set, it will basically fill in that variable, and you could have it spit it out to you. So these are variables that are set upon output, or set as output. And so that is, you input all the Terraform templates that you set up, and basically you can output these things. You can also use these outputs to be able to easily query information about it. So you can set up a bunch of these outputs, and then you can easily find out what those things are. So if you want to know, at the end, if you want to know after the run, what any of these options were, I want to know what private IP there is, or I want to know which key name was used, or what the new key name is, or password data. You can get that information afterwards. And then, so we're gonna quick through that. Modules. Modules are great. Modules are an excellent part of Terraform. Again, it's not something that I think we need to, it's something you should absolutely know about, not something that I think we need to do an example of. But basically what modules are is, you don't always want to, write out a bunch of manually write out all this code. So let's say I had tons and tons of infrastructure. I don't necessarily want to do it this way. Think about functions in programming. You write a concise little piece of code that performs a task. Modules are the same way. It's really just a folder with some Terraform files in it, but it's set up and it's configured and constructed in a way that this stuff is reusable elsewhere, and you can use these modules to easily be able to kind of create repeatable pieces of code and rerun different things. So you don't have to keep rewriting things. Modules are great because you can share them with people and people can grab them. So there's this Terraform registry, and so you can go in and you can get a module that will allow you to easily set up a lot of things. So an RDS instance, it comes with this module, and it makes it very easy for you to set up an RDS instance, and again, it makes it very easy for you to do so. So modules are great. Understand what they are. Take some time. You can try out a module yourself to be able to do that. And actually, I think the stuff we're using now, for these providers, all this AWS, this AWS stuff and this resource, I'm pretty sure it's coming from the AWS module that gets downloaded when I do a Terraform init from there. So I think we're using pieces of modules right now. Ignore the rest. Remote state storage. This is the most important piece. We talked about all the rest of the stuff. This is the part that you need to know when we get out of here as well. This is very important. So let's read a little bit of it. So you have now seen how to build, change, and destroy infrastructure from a local machine. This is great for testing and development, but in production environment, it is more responsible to share responsibility for infrastructure. So you or me shouldn't be the only person who has access to manage your infrastructure, and there should be a shared model around that. The best way to do this is running Terraform in a remote environment with shared access to state. What is state? State is the state, or the current kind of snapshotted setup of a current deployment. So the state matters. We need to know, basically, a state is like the version, or the I don't want to use the state that it is in, but it's the current running setup of your infrastructure, and that's what the state is. And so Terraform creates a file. When you run that Terraform plan or a Terraform apply, and you go ahead and implement that, it creates a file here called terraform.tfstate. And basically, this is a file that lets Terraform know the current state of your infrastructure. After it goes in and it spins stuff up, it goes ahead and it saves basically the current state of that infrastructure. And Terraform needs this. It's very important that you don't delete this file or do anything with this file. It needs this Terraform state file, especially if you're working with other people. And so what you do is you want to have this, because you're working with other people, this Terraform state file needs to be somewhere remote, so that different people's computers can access it when you go ahead and try to manage this infrastructure. And so that's basically the piece that you need. That's basically the point that you need right now. You need to understand what state is, like the current setting of the infrastructure. You need to understand what state it is, and you need to know that it's best handled remotely for multiple people. So if you're the only person managing your infrastructure, so if you're just messing around with Terraform, you don't need to do this piece. No big deal. Have your Terraform state locally. Just keep it in your directory. Great, works great for testing. But for any infrastructure where multiple people are working on it, this state file needs to be shared. So again, use a lot of ways to do this, or some of the common ways to do this, is that Terraform has their own Terraform cloud, which you can use to easily set up a remote backend for this. And basically, they'll handle it all. You basically just configure. You basically just throw this little bit of code into your Terraform file and your .tf file, and it'll go ahead and it'll use the Terraform backend, or the Terraform cloud, or the HashiCorp cloud, or whatever, to be able to use the backend that manages your remote state. Now, since we've been learning AWS, the way that you might want to do it if you're on AWS, or a common way, is one, you'll use S3 for this. So basically, we talked about S3 being a simple storage service. This is an object storage service. You set up a pipeline. You basically throw this terraform.tf state file into that S3 bucket. You'll also set up DynamoDB. Usually, not always, but it's highly encouraged that you set up DynamoDB as a method to manage lock, basically. So if it's important to know if one person is updating infrastructure. So if I go ahead and make some changes and I go to update infrastructure, what happens if you're working remotely from me and you go ahead and deploy too, and it checks the TF state, and obviously it updated the TF state, and now you've grabbed it and everything, and I made my changes, but since they're not done, the final TF state file is not in the bucket, and you go ahead and start to try to deploy. And basically what would happen if there's no lock file is my stuff would take effect, then everything would get updated in the bucket, and then because your stuff is running, it would make different changes because it would think certain things were there before my changes got in there, and it gets all weird, and you have this weird, super messed up infrastructure state because two people are trying to deploy at the same time. This state lock basically says, hey, the state, it runs a check against Dynamo. It says, hey, state's locked. No one can update right now. No one can grab this. No one can update this configuration because it's currently locked, and you gotta wait until the run is done. The lock will get, someone's run will finish, my run will finish, the lock will get removed from DynamoDB, and then the next person can go ahead and make the run. Again, this is great so that you're not, infrastructure changes can be large, and it can get into a real weird state if multiple people are deploying all at once. So this makes sure that everything is working properly and that the current state and the current set of changes are managed accordingly. And that is a very important piece of it. You don't need to see it. I don't think you need to see it in action, but you do need to understand state. You do need to understand this TF state file, kind of what it is and what it does in terms of Terraform, and why you would probably need to set up a locking mechanism. I believe the Terraform cloud, I believe it sets up a locking mechanism for you. I think that's part of what it does. Terraform is now storing your state remotely. Remote state storage makes collaboration easier. It keeps secret information off your local disk. That's another benefit as well. But the main reasons of it are what I said just a bit ago. Yeah. All right. So what else do they have in? That's a really important topic. And then we've kind of gone through everything. Next steps, it'll give you some more stuff. So if you want to run through this yourself, it'll basically just give you some more options to learn. But that's basically everything from this. So you saw how easy it was to, one, install Terraform, how to provision infrastructure. We did an EC2 instance and Elastic IP. I also copied and pasted a little snippet for an S3 bucket. Actually, let me paste where the docs are to where you can see this stuff. So the docs are here. And again, get comfortable with looking through documentation. So I encourage you to take a look and see what you can find. There's a term glossary. Just kind of read through Terraform Cloud, CLI. So if you have any questions, you can kind of go through and find some stuff and try some things out. So if you want to know what to do from the CLI, you can go through here and figure out what commands they have and what each of the commands does. And what plan and import does and graph, all kinds of stuff here. You have a lot of options available to you, but the docs will teach you how to spin up some stuff. If you want some Terraform AWS docs, again, don't be afraid to Google it. Just Terraform AWS docs. Pretty simple. It'll take you right here. I never remember the pages for stuff. And it's in the provider section, and you can see in here how to use all AWS stuff. If I want to spin up a DynamoDB table, looks like I can go ahead and copy basically what we have here, follow their example, and set things up fairly. Documentation like this is hard to read at first. I think their documentation is great. That's why I encourage you to take a look at it and to try some stuff. Remember this follows the same paradigm: resource, the name, the type of resource, so DynamoDB table, and then the ID or the name that Terraform is going to apply to it is right here. Same setup as we did with EC2, same setup as S3, same exact setup as our Elastic IP. So pretty simple, I hope. Read through this learn page, run through it again on your own, actually read through the things that it said in here, so that you can kind of understand everything in there a little bit deeper. There's some decent information in some of these paragraphs that we kind of skipped over, that'll teach you a little bit about AWS as well. So go ahead and try that out. But other than that, that's Terraform. That is the first half, first third of infrastructure as code. We already learned some stuff about scripting, but the first half of what we're going to be doing this week, we'll take it a little further. So after we provision the infrastructure, like we did today, we'll provision the infrastructure. Then we'll use a tool like Ansible to go ahead and set up all the things that we want to set up on the server with that, and it'll be pretty cool. And then you'll understand from start to finish how you would codify a complete infrastructure, which is pretty fun. That's probably all we have for tonight. I'm gonna stick around and answer some questions. I know you guys asked a lot of questions last time. There's a lot I didn't get to right now, but hopefully, again, like I said, hopefully we got a lot out of that. For anyone who wasn't on earlier when we first talked about the announcement that on next week on Wednesday, we're supposed to be doing the containers part 2. The live portion of that is actually going to be done on Tuesday. So Monday, we're going to do containers part 1. Tuesday, we're going to do containers part 2. It is okay if you can't make that. Twitch has a replay function. I've been learning a little more about Twitch. I learn a little more each week. Has a replay function. We'll record it live on Tuesday. So if you need to ask questions or you're interested in asking questions, hop on Tuesday if you're available. But it will replay live on Wednesday because I'll actually be away at a conference. I'm going to do my best to log on while it's playing, so that if you do have questions, then I'll be on to at least answer them via chat, but I will not be answering them on stream. It'll just replay what was recorded on Tuesday. So that's pretty cool. It's a pretty cool feature. So again, next week is gonna be Monday and Tuesday rather than Monday and Wednesday, but you can still watch it Wednesday if you'd like. NLP Containers Part 2, that kind of hurts me a little bit because I hate getting off schedule. Especially for the container part. I like teaching containers the most. Containers are fun. Like, this is going to be the containers are going to be the most fun part for me. But yeah, again, Monday and Tuesday next week for that, if you can make it. But yeah, I'm going to BitCon. BitCon is actually the Blacks and Technologies conference out in Minneapolis, Twin Cities, Minnesota. And I went last year was the inaugural year. It was the first one, which was pretty fun. It was pretty dope. You know, I got to actually see Nipsey Hussle in person. If you didn't know who Nipsey Hussle was, he was a rapper. He actually got killed earlier this year, or into last year, earlier this year. He was actually there doing a panel. He was big in entrepreneurship, kind of big into the tech game. So that was pretty interesting. Got to see a lot of cool places. I didn't know there's a lot of companies that have come out of Twin Cities, like Target, Best Buy, a lot of big companies. So it's cool to kind of be a part of. Like, a lot of them let us, some of the events that we hosted were kind of in those buildings, and we kind of got to see some cool stuff about how they did things. So it was pretty dope. If you get a chance to get out to any tech conferences, you know, take the opportunity to get out to tech conference, meet some people, you know, listen to some talks. That'll help immerse you again in this world of tech as well. If you need some advice on which ones to go to, I can give you a whole list of ones to go to. There are all types of ways to go for free at your company, but there are also different conference scholarships and the ways to get there for cheap. So definitely, you know, another way to bolster your learning and to have some fun, because conferences are also usually pretty fun, and to learn at the same time. Definitely try to get out to some conferences if you want. But like I said, I'll be going to one next week. I'll actually be going to, this is the last one I'll be going to during this first boot camp, but I'll be going to a few more this year as well, but I don't think they'll coincide with a boot camp. But I will be continuing to stream. I will be continuing to stream after this boot camp is done. I will be continuing to stream twice a week, various topics. We're probably doing smaller workshops. We'll probably dive deeper on some of the things like containers. Like, we might do some bigger stuff with Terraform. Maybe do a 2-week 4-part session on Terraform, building some much larger infrastructure, things like that, until the new year. After the new year, when the new year starts, I will be redoing this bootcamp, and I will also be doing probably the introduction to coding using Python bootcamp. That probably will only be 10 weeks. But I'm probably running them concurrently. And I might actually try a different setup for that. I'm going to do a little polling. I might have one on like just Sunday, like 3 hours every Sunday, like 1 in the morning, just to kind of allow different people to have access to it. So I actually might, because I've run this DevOps bootcamp during the week, I might move this one to Sunday and run the Python one during the week. So I'll try to run 2 at once. And I'm actually working with someone to maybe have someone else come on and teach another topic. So the goal is to be able to run a few of these at a time, because, you know, it's not that much of a time commitment per week, you know, once you get the curriculum set up, and it's fun. And I think there's a lot of topics that people find beneficial. So we're going to be trying to ramp those up for right after the new year. But up until the new year, we will still be streaming. We will still be talking about some in-depth topics. So if you have any ideas or anything you want to see or anything you want to talk about, even something I have no idea about, we'll hop on and we'll learn it together. Like, maybe I can show you my process for learning new technologies. We can go through and I can show you, hey, I don't know everything at all. And maybe we can, you know, take something brand new and figure out how to do some stuff. I did want to try to live create some, I have some ideas for some cool Twitch plugins that we could build, you know, to integrate kind of with the stream that might make it a little more interactive, fun, and useful for people. That I thought might be cool way to learn how to code as well. But yeah, so if anyone has any ideas, throw them at me. And there's also going to be ways to, so I'll also be doing with anyone who is subscribed, if you're interested, there's an extension for to like live share via VS Code. So you can real time collaborate with other people, kind of like Google Docs. And so multiple people can be coding in the same repo at once, and maybe kind of hopping on. And anyone who's interested, feel free. Maybe we'll like hop on Google Hangouts or something, and we can kind of all work on a project together, live on stream. I think that would be fun. I think there's definitely opportunities there for people to teach me stuff. Like, again, before I was like, oh, how do you know so much stuff? I was like, I know a lot of different things. I know there's some things I'm great at, but there's a lot of things that I'm terrible at, and I need to learn a lot more about, and I would love to learn from you all as well, and we can hop through, maybe build some cool things and try out some cool things. So if anyone is ever interested in doing that, let me know. I don't know how many people you can live share with at once or can work on a repo at once, but we can try it out. I would like to do also something called mob programming, which is basically for anyone, especially for anyone who's new to coding. This would be great for you. Basically one person at a time is driving, so it's typing, so the one person at a time is typing, and everyone else will be telling them, we'll be trying to solve a problem, and we'll tell you what to type. So even if you don't know what to do, even though you're typing, we're telling you exactly what to do, and there's a time limit, and we'll run through, and for a while, you'll be typing maybe for 3 to 5 minutes, and you'll listen to what everyone else says, and you'll let them go through their thought process, and you just go ahead and type what they say, and then someone else will get to type, and then you'll get to be a part of participating in the group think and trying to solve the problem. And I think it's a very effective way to, one, get you comfortable, like get people who don't know how to code at all comfortable with like working with other people and like working through a problem. It's very hard to figure out how to work through a problem like on your own if you're new to this stuff. But when you start to get in that group thinking, you just start to see what thought process people have, because it's not like, okay, now we need to use this function to do this and that. And it's like, no, like, hey, we want to make sure that we find the square root of this number, but we don't have that available to us. So maybe we need to break the number down smaller, or maybe we need to do something like that. And you can kind of talk through your ideas with people, and it makes it a lot easier. But yeah, again, I'm also this current session is mostly a pilot to kind of see how this would go, see what works, see what doesn't work. So I'm actually going to be creating a Google feedback form for like anyone to, like, any feedback you have. If you love me, if you hate me, if you like something we did, if you hate something we did, like, let me know. None of that's going to hurt my feelings. I really want to make this powerful for as many people as possible. So let me know. Like, I genuinely write down all the things. I think someone said, like, when we got to the cloud section, that I should have had a fog machine and, set it off and talked about like demystifying the cloud. Yeah, we're gonna do stuff like that. Like that. I think that'll be fun, engaging. But if there's any ways you think that are better to do certain things, let me know. I'm all ears for all of those things. People have been providing great feedback in Slack, so thank you for that. And everyone always approaches me like kind of on their like they're walking on eggshells. They're always like, hey, like, I hope this is not too forward, but blah, blah. And I'm like, no, like, that's great. I love that information. Doesn't bother me at all. If you have any feedback at all, you can send it to me through Slack, but I'm going to work on a way of aggregating it through Google, through a Google feedback form. So keep an eye out for that. But thank you very much for joining in tonight. Hope you learned a little bit about Terraform. Hope you understood a little bit about infrastructure as code as well. Does Elastic Beanstalk do some provisioning for you? Yes, it does. What is the use case for using something like Beanstalk versus Terraform and CloudFormation? Absolutely, that is a great question. I love questions like this. So Elastic Beanstalk is simply it really is just an earlier technology that was created to kind of solve this exact problem. Like, how do you take a developer and give them a resource to be able to repeatably provision resources for them for quick development? Elastic Beanstalk is exactly that, but it's a little primitive. It's primitive. It's designed for developers, so it is the way that you have to use it is. It's very opinionated, and they only give you a few options. So you have a small feature set to be able to do things. So Elastic Beanstalk does provide some of that same functionality for you. Here's where the breakdown is. For development purposes, I actually think Elastic Beanstalk is a great option. Where the differences matter are at scale. when you need things to be a little more elastic, when you need things to serve a larger scale, and you need more of those options, that's where you would dive into Terraform and CloudFormation to provision those resources rather than Elastic Beanstalk. Elastic Beanstalk, even though people do use it as a to serve apps and things like that, it is more suited towards the development purposes and towards a small application, not really for the enterprise. Not really for the enterprise user. You want to use CloudFormation and Terraform for something like that. So that's a great question. I started to kind of sign off, and that was for people, hard stop. It's 10:23. There's only supposed to be 2 hours. If you need to go, feel free to go. Again, I'll stick around. I like questions like this, for anyone who has questions like this. But if you can't stick around, we're not going to be learning anything. You might learn something new from the questions, but we're not going to be going over anything specific. So feel free to get out of here if you need to. I really appreciate you all staying this long. Will all the previous videos be on YouTube just showing today? Yes. So episodes, streams 1 through 11 are already on YouTube, and you can do the ! YouTube command to get the YouTube link. And so the last 3, as soon as this is done, I'm going to render out the current 3 that I have. I have to render them out because I have to remove, I play some music in the very beginning for the starting soon tracks, and I have to remove those so that YouTube doesn't copyright strike them. And these are all over 2 hours, so it takes a bit for them to render on my computer, but absolutely the next 3 will be uploaded by tomorrow. I'm going to render them all out tonight, take them into work. We have fast upload speeds at work, so I will upload them at work tomorrow. So, but 1 through 11 is already on there if you want to check out 1 through 11. And also, a YouTube video is dropping tomorrow. I'm changing the YouTube drop date from Friday to Tuesday. So I will have a YouTube video dropping tomorrow as well. And I started recording a few other ones, so I have some in the pipeline. I think I can keep up the Tuesday release cycle for a while. So we'll work on that. Again, YouTube, a lot more work than Twitch. I do like Twitch because you just kind of hop on and go, and whatever happens, happens. There's too much thinking for YouTube. There's too much pre-planning. There's too much post-planning. There's too much watching it back and being like, that sucks. Like, I can redo that. And it's like, you'll never get anything done that way. So I'm gonna, I know it takes time to get good at that stuff. I'm just learning how to video edit, just learning how to properly record certain scenes and learn about lighting and all that other stuff. So like, I'll get over it. I'll release it. Give me feedback, and I'll try to make some cool things. But I do like the creativity that you can have on YouTube, like the kind of creativity you can have with editing. Like you can really make some fun things that are also beneficial and educational. I have a stupid question. I'm new here. What do you usually stream? I see your YouTube channel looks amazing. Can't wait to watch. Yeah. So this is kind of. I usually stream some type of technical training. So this current 12-week, we're in the 8th week of a 12-week boot camp. We're teaching DevOps. So DevOps is a methodology, or really kind of a job title in the tech industry. And so that's what we're learning how to do over these 12 weeks. We'll be doing more than that though. You can check out academy.mastermind.io to learn more about what we're going to do, but we're also going to be streaming coding. We're going to learn how to program. We'll probably be streaming all kinds of other things related to the tech industry, and tech specific, I guess, tools and resources that you need to learn to be able to get a job in tech. And that's mostly what we're going to be covering. Every now and then though, we will be doing some gaming. So November 2nd, I think that's the day, the national day for Extra Life. If you don't know what Extra Life is, it's a way to raise money for various charities. I think you can choose, but for children's hospitals is what most people play for. But for 24 hours, we'll be live streaming some games. We'll be playing video games for 24 hours, I think on November 2nd. So that'd be fun. I don't really know if I can play video games for 24 hours, but we're gonna try. I'm gonna get together with a couple other people, so keep an eye out for that. I'll also, every now and then, I'll stream some games on here too, just because I like to play games, and I know other people like to play games, and just another way to just kind of unwind. We don't need to be stressing over tech all the time. So do that, but mainly this is going to be a channel around learning different technologies. Can I help by creating a channel and coordinating group coding? Absolutely, yeah, no. yes, you can absolutely create a channel and do it that way. However we want to organize is great. I love that. Thank you, Shook, for that. I would actually really appreciate that. Yeah, I would love for you to create a group and we can get around group coding, because we can also do some ad hoc sessions. You don't need to wait for the stream to be able to work with each other. Again, that live share feature on VS Code is great. And even let me know if you guys are working on something and you want to just grab a group of 5 or 10 people and hop on, again, like a Google Hangouts or something, or a Zoom call. We can kind of go through stuff, because I'm, usually after work, if I'm not hanging out with my wife or my dog, I'm usually learning something or working on something to learn. So I will be happy to do that. Also, if anyone is studying for any AWS courses, maybe we can set up in like a study group or something for AWS exams, because that's what I'm currently studying for. I'm studying for one of the AWS Pro exams. So if you want to do that, absolutely, a lot of opportunities for that. Cool. All right, I'm actually gonna sign off now. I'm gonna take the dog out. I'm gonna get a little food, and then I'm gonna hit the bed before I'm trying to, again, I'm on this big workout kick, so I wake up pretty early to go work out. So I'm gonna make sure I'm up for that. Saw your DevOps days. We're gonna see you at reInvent too. Yes, I am going to reInvent this year. I'm gonna take my Solutions Architect Pro at reInvent. Cool, you're taking your essay in 2 weeks. I think I'm gonna take it. I think I'm going to take the associate just to re-up on on my certs. Both of my certs will be expired in November before reInvent, and I don't want to fail the pro at reInvent and not be able to do all the cool stuff that people who are certified get to do. So like Amazon, they got lots of money. This conference is very expensive. If you are certified, they give you like access to all these like private like little areas with like special food and all this other stuff. So it helps if you're certified when you go there. So I might take an associate so that I am certified before I go there, just in case. I know the pro is pretty tough before I go there, so it's cool. I was off on the morning workouts. I used to swim yeah, I mean, I feel so much better when I work out in the morning. Like it's easy to skip in the evenings. It's not hard for me to get up. The problem is I always put off stuff until late at night, and then if I work late, then I can't wake up early. So that's the problem. So I'm gonna try to take care of everything I need to take care of so I can get to bed. As long as I get to bed I wake up at like 5:45 to go work out. As long as I can get to bed by 12:30, 1 o'clock, I'll be fine. I'm good to go. But yeah, like I've been doing all kinds of stuff for Mastermind, all kinds of stuff for work, and I don't get to bed till late, and so that keeps me from working out. So I want to make sure I am working out, because again, so I turned 30 in March. By the time I turn 30 in March, I want you guys to look back at these videos and look at this one and be like, and look at the current videos and be like, man, like you're taking up so much less space on the screen. I want to be a lot smaller. I want to lose a lot of weight. So we'll see what happens. Gotta look good before I'm 30. So yeah, thank you again. 10:30. I'm gonna sign off now. Appreciate everything. Appreciate the questions. Yeah, all good. Appreciate that. Weren't that big when I saw you. Yeah, I take up a lot of space. I just want to take up less space. Like I don't particularly think I'm really fat or anything like that, but I just want to take up less space. But cool. Yeah, thank you. I'll see you all on Wednesday. Get ready for some Ansible stuff on Wednesday. I'll see you then. Have a good night.